So welcome students. In this topic, let us look at the introduction of the topic, properties of triangles. So we have come a long way in our study of trigonometry. Initially, we have studied trigonometry as the ratios in a right angle triangle. We have taken a right angle triangle and defined different trigonometric ratios as the ratio between the sides of a right angle triangle. Then we have moved on to study trigonometric ratios as functions which take in certain values of theta and gives out the values of trigonometric functions. In this topic, what we do is we try to use the concepts that we have learned till now, that is the concept of trigonometric functions and trigonometric ratios, to find the relations between the sides and angles of a general triangle. So if you have a general triangle, so let us say that the vertices be A, B and C. The side opposite to vertex A is usually called small a. The side opposite to vertex B is usually denoted by small b. The side opposite to vertex C is usually represented by small c. So in a triangle, you have three vertices, three angles, angle A, angle B, angle C, and three sides. So in this topic, what we are going to see is some relations between the sides A, B, C, angles A, B, C. So how will these be related to one another? In different ways. And to understand that, we use some notations in this chapter. These are standard notations which you need to remember. The first notation is the notation of semi-perimeter. So A plus B plus C, obviously if you add the sides, we know that it represents the perimeter. So A plus B plus B by C by 2 is called the semi-perimeter, that is half of the perimeter, and this is denoted by S, a letter S. So whenever you see S, you need to understand A plus B plus C by 2. And we know that every triangle will have a certain inradius and a certain circumradius. So you have an incircle to a triangle, you have a circumcircle to a triangle. The radius of circumcircle is called circumradius, the radius of the incircle is called inradius. So the inradius is usually denoted in this chapter by small r. The circumradius in this chapter is denoted by capital R, and the area of the triangle is denoted by delta. So these are the standard notations that we are going to use as we go on in this chapter. So once you understand what we are going to deal in this chapter, come, let us go deep in this chapter. In this video, let us look at the first and the most important rule in triangles, which is called sine rule, which says that A by sine A is equal to small b by sine capital B is equal to small c by sine capital C is equal to 2 times the circumradius. The side A by sine of the angle opposite to side A is equal to small b by sine B is equal to small c by sine C. That is, this side by sine of this angle is equal to this side by sine of the opposite angle is equal to the third side by the sine of the opposite angle. And all these three ratios will be equal to 2 times the circumradius. This is the theorem. So let us see why this theorem works. And after that, let us see how this theorem can be used to solve problems. So first, so let us take a triangle ABC. If you take any triangle ABC, there can be 3 cases. ABC can be an acute angle triangle, a right angle triangle, or an obtuse angle triangle. And in these 3 cases, let us prove that A by sine A is equal to 2R. Whatever may be the nature of the angle A, if you show that A by sine A is always equal to a constant 2R, Obviously by symmetry, B by sine B and C by sine C will also be equal to 2R. Now, first let me take an acute angle triangle. So if you take an acute angle triangle, obviously the circumcenter lies inside the triangle. Now, how can I prove that A by sine A is equal to 2R? I use certain properties of circles. So first what I'll do is I'll draw a diameter through B. So I'll draw a diameter through B. So if this is capital R, this is also equal to capital R, right? Now let this point be P. I'll join PC. Now we have a standard property in circles which says that angle in the same sector is equal. That is, the chord BC is subtending an angle of A as well as P on the same sector. Hence angle A has to be equal to angle P. So angle P has to be equal to angle A. And because BP is the diameter, this angle has to be equal to 90 degrees. Angle BCP has to be equal to 90 degrees. These are the two conclusions that I draw. First is angles in the same segment are equal. The second is angle in a semicircle is equal to 90 degrees. Now, in this right angle triangle, what is sine P? Sine of P is nothing but opposite side by hypotenuse. So in this triangle BCP, which is a right angle triangle, BP is the hypotenuse, A is the opposite side to P. So A by the hypotenuse is nothing but 2 times R, which is the diameter. And this implies angle P is exactly equal to angle A. So sine of A is equal to A by 2R. This implies A by sine A is equal to 2R. So I have taken an arbitrary vertex and an arbitrary opposite side, and I have proved that this side by sine of opposite angle is equal to 2R, which is a constant. So by symmetry, B by sine B and C by sine C should also be equal to 2R by a similar derivation, so which you can do. So A by sine A is equal to 2R works if angle A is acute. Now let us see whether it works if angle A is a right angle triangle. So let us say that angle A is a right angle triangle. So obviously the side opposite to A should be the diameter. So this is R and this is R. Now what is small a? Small a is equal to 2R. So small a by sine A is equal to 90 degrees. So sine A is 1 should be equal to 2R. Because if this is 90 degrees, sine A is equal to 1. So A by 1 will always be equal to 2R. Because the side opposite to capital A is BC, which is equal to 2R. So that means if A is a right angle, also A by sine A will be equal to 2R. So now let us see if the same result holds if A is an obtuse angle. So if A is an obtuse angle, obviously the circumcenter will lie outside the triangle. Now if the circumcenter lies outside the triangle, so you can always draw a diameter from B. Let us say it as BP. Let the center be S. And if you join P to C, the angle will be 90 degrees because angle in a semicircle is 90 degrees. Now BPC is a right angle triangle and ACPB is a cyclic quadrilateral. Do you remember any properties of cyclic quadrilaterals? Yes, the sum of opposite angles have to be equal to 180 degrees. So angle P has to be equal to 180 degrees minus angle A. So let us say this equal to theta. So let us say this as theta. So now in this triangle, this is capital R, this is capital R, and this side is the side opposite to A. So this is small a. So what is sine theta? Sine theta is equal to opposite side A by 2R. And what is theta? Theta is 180 minus A. So sine of 180 degrees minus A is equal to A by 2R. What is sine 180 minus A? It's nothing but sine A itself. This is 2 into 90. It's in the second quadrant and the number is even, so sine becomes sine. So sine A is equal to A by 2R, and this implies A by sine A is equal to 2R. So whether A is acute, A is a right angle, or A is a obtuse angle, A by sine A will always be equal to 2R. By similarity, B by sine B will also be equal to 2R, and C by sine C will also be equal to 2R. That means in a triangle, this sine rule always works. And what is the importance of sine rule? So the sine rule says that the ratio of the sides ABC is same as the ratio of the sines of the angles opposite to them. So sine rule gives you the ratio of the sides of the triangle. So if you have a triangle whose angles are 30 degrees, and 120 degrees. So we have three angles as this. What is the ratio of their sides? The sides will be in the ratio of their corresponding sines. That is 1 by 2 is to 1 by 2 is to sine 120 is root 3 by 2. So the sides will be in the ratio 1 is to 1 is to root 3. This is one result which gives you the ratio of the sides if the angles are known. So let us take an example where sine rule can be used. So in the question you're given that the perimeter of a triangle is 6 times the arithmetic mean of sines of the angles, and the side opposite to vertex A is equal to 1. You're asked to find the angle A. So you can solve this using the basic formula. So the perimeter of a triangle is nothing but A plus B plus C is equal to 6 times the arithmetic mean of sines, that is sine A plus sine B plus sine C by 3. The sum of the sides of the triangle is equal to 6 times the arithmetic mean of sines. So this cancels out 2 times. Now one side you have the sides, the other side you have the sines. The sine rule connects the sides with the sines. So we know that A by sine A is equal to B by sine B is equal to C by sine C is equal to 2R. So small a is equal to 2R sine A, small b is equal to 2R sine B, small c is equal to 2R sine C. So this implies A is equal to 2R sine A. So in all these you have 2R common. So 2R times sine A plus sine B plus sine C is equal to 2 times sine A plus sine B plus sine C. So these two are getting cancelled. So this 2 and 2 also are getting cancelled. This implies R is equal to 1. So from the first information you got the circumradius as equal to 1. Now once you have this, you have the side, you can easily find the angle. So we know that A by sine A has to be equal to 2R. This implies 1 by sine A has to be equal to 2 into 1 is 2. This implies sine A is equal to half. This implies A is equal to 30 degrees or 150 degrees. So the angle A can either be 30 degrees or 150 degrees. These are the two possible answers for this question. So let us take another example. So in this question you're given that angle A is equal to 75 degrees, angle B is equal to 45 degrees. And you're asked to prove that B plus C root 2 is equal to 2A. So you're given two angles, that means effectively you're given all the three angles because the sum of angles is 180 degrees. So if angle A is equal to 75 degrees and angle B is equal to 45 degrees, So angle C will be equal to 180 minus 75 minus 45. 75 and 45 combinedly gives you 120. So the remaining angle is 60 degrees. And once you know the angles, what does sine rule say? A by sine 75 degrees is equal to B by sine 45 degrees is equal to C by sine 60 degrees is equal to 2R. This implies A is of the form 2R sine 75 degrees. Sine 75 is nothing but root 3 plus 1 by 2 root 2. That is equal to R times root 3 plus 1 by root 2. Next, B is of the form 2R sine 45 degrees. 2R sine 45 is 1 by root 2. That is equal to R times 2 upon root 2. And C will be equal to 2R times sine 60 degrees. 2R times root 3 by 2. That is equal to R times 2 root 3 by 2. 2 root 3 by 2. So this is how ABC looks in terms of R. Now you're asked to find this. You're asked to prove this. So let us take the LHS and the RHS and see whether both are same or not. So if you take the LHS of this left hand side, so B plus C root 2 is nothing but B plus C times root 2. That is R times 2 by root 2 is root 2 plus C times root 2. If you multiply this with root 2, you get 2 root 3 by root 2. That is equal to R times 2 plus 2 root 3 by root 2. That is equal to 2R times root 3 plus 1 by root 2. Or I can write this as, I can leave it here. So, and you can very clearly see that R times root 3 plus 1 by root 2 is nothing but A. So I can write this as 2 times A, which is nothing but the RHS. So from LHS I have gone to RHS, and this result is proved. So in this video, let us look at the next formula, which is called Napier's rule. So Napier's rule says that tan of B minus C by 2, the difference of two angles by 2, is equal to B minus C by B plus C times cot of the remaining angle by 2. And you have different formulas of this form. If you have B minus C by 2, you have B minus C by B plus C into cot A by 2. We have C minus A by 2, we have C minus A by C plus A into cot B by 2. So what are the two angles that are used here? You got the other angle here. Tan A minus B by 2 is equal to A minus B by A plus B times cot of C by 2. So you can write the other formulas also. Tan of C minus B by 2 will be C minus B by C plus B times cot A by 2, so on. So let us try to see how these formulas are obtained. So these formulas are derived from sine rule. So let us take one of these and derive this. So what does sine rule say? Sine rule says that A by sine A is equal to B by sine B is equal to C by sine C is equal to 2R. So this we have already derived. If you take any two of this, let us take two of them. From this, can I say that A by B is equal to sine A by sine B? Right? A by B is equal to sine A by sine B. And this implies, so if you use component and dividendo here, you use component and dividendo, A minus B by A plus B is equal to sine A minus sine B by sine A plus sine B. That is equal to, so this implies A minus B by A plus B is equal to, so here you have sine C minus sine D by sine C plus sine D. You can use transformation formulas. What is sine C minus sine D? 2 sine A minus B by 2 into cos A plus B by 2. divided by, what is sine A plus sine B? 2 sine A plus B by 2 into cos of A minus B by 2. This 2 and 2 gets cancelled. Sine A minus B by 2 by cos A minus B by 2 is tan A minus B by 2. Tan of A minus B by 2. And what is cos A plus B by 2 by sine A plus B by 2? This cot of A plus B by 2. So if cot A plus B by 2 comes on to this side, it becomes 1 by cot A plus B by 2 or tan A plus B by 2. So this implies tan of A minus B by 2 is equal to A minus B by A plus B times tan of A plus B by 2. Now we know that ABC is a triangle. So A plus B plus C is equal to 180 degrees. So what is A plus B? 180 degrees minus C. What is A plus B by 2? 90 minus C by 2. So what is tan of A plus B by 2? That's nothing but tan of 90 minus C by 2, which is equal to cot of C by 2. So this tan of A plus B by 2 will be converted into cot of C by 2. That is equal to A minus B by A plus B into cot of C by 2. So we have derived the last formula. So if you take these two, you got the relation between A minus B. If you take these two, you get the relation corresponds to B minus C. If you take the first and last, you get the relation correspond to the second equation. So in this way, you can derive the rule called Napier's rule. So what does this rule say? Tan of some angle minus some angle by 2 is equal to the difference of the corresponding sides by sum of the corresponding sides into cot of the remaining angle by 2. So this Napier's rule will be used in questions involving tan of B minus C by 2 or cot of A by 2. So you can very clearly see in the question. If the question contains terms like this, or this, or this, we usually use the Napier's rule to solve those questions. So let us take an example. So in this question, you're given that angle A is equal to 60 degrees. The ratio of B and C is root 3 plus 1 is to 2. And you're asked to find angle B minus angle C. So seeing angle B minus C, you remember Napier's rule. So which says that tan of B minus C by 2 is equal to B minus C by B plus C times cot of A by 2, right? So angle A is given, so cot A by 2 is very straightforward. B is to C is given, so B minus C by B plus C is also very straightforward. So you can find these two terms very easily. So cot A by 2 is nothing but cot of 30 degrees, which is equal to root 3. And B by C is equal to root 3 plus 1 by 2. So if you use component and dividendo, B minus C by B plus C is equal to root 3 plus 1 minus 2 by root 3 plus 1 plus 2. That is equal to root 3 minus 1 by root 3 plus 3. That is equal to root 3 minus 1 by root 3 times root 3 plus 1. So B minus C by B plus C is this. So once you have both of these values, let me substitute these two values. So tan of B minus C by 2 is equal to B minus C by B plus C is root 3 minus 1 by root 3 times root 3 plus 1 times cot A by 2 is cot 30, which is equal to root 3. So root 3 and root 3 gets cancelled. So root 3 minus 1 by root 3 plus 1 corresponds to tan of how much? Tan of 15 degrees, right? This is a standard value, root 3 minus 1 by root 3 plus 1. Tan of 15 degrees. So this implies B minus C by 2 on comparison is equal to 15 degrees. This implies B minus C is equal to 30 degrees. So the value of angle B minus angle C is 30 degrees. So that's the answer to this question. In this video, let us look at an important property of a triangle, which is called cosine rule. So this cosine rule will be useful to find the angles if the sides of the triangle are known. So assume that you know the three sides of a triangle and you are asked to find angle B or angle A, so on. So cos of angle A is equal to B square plus C square, the sum of squares of adjacent sides, minus the square of opposite side, B square plus C square minus A square, divided by 2 times the product of the adjacent sides. So this is what cosine rule says. Similarly, if you want cos B, what you just need to do is you just need to square C square plus A square minus B square by 2AC gives you the value of cos B. If you want cos C, A square plus B square minus C square by 2AB will be the value of cos C. So if 3 sides of a triangle are given, cosine rule gives you the formula to find each of the angles of the triangle. And this cosine rule can be used in the other way also, which is this way, which comes after the cross multiplication. So A square is equal to B square plus C square minus 2BC cos A. If 2 sides are given, if 2 sides are known and the angle between them is known, if 2 adjacent sides and the angle included between them is known, from these 3 informations you can find the opposite side. For example, B square will be equal to A square plus C square minus 2AC cos B. So you have 3 formulas of this type, 3 formulas of this type. One formula for cos A, the other formula for cos B, the other formula for cos C. Here also you have one formula for A square, one formula for B square, one formula for C square. So you just need to follow the pattern. So if you want cos B, you need to write A square plus C square minus B square by 2AC. So whatever angle you have here, that comes at this point. The other sides will come at these 2 positions and the denominator positions. So now let us see a sample derivation for the cosine rule. So if you take a triangle ABC, so to derive the cosine rule, what the construction that we do is drop a perpendicular from A onto the side BC. So let the foot of the perpendicular be D. Now the side opposite to vertex A is small a, this is small b, this is small c. Now this angle is C, so triangle ADC is a right angle triangle. So in this triangle, what is sine C? Sine C is nothing but opposite side AD by AC is B. This implies AD will be equal to B sine C. So this side will be equal to B times sine C. Now if you take the cos of angle C, cos C is equal to CD by B. This implies CD is equal to B cos C. So this is B sine C, this is B cos C. This is the cos component, this is the sine component. Now if this is B cos C, what is the length of BD? BD is nothing but A minus B cos C, right? So this is B sine C, this is A minus B cos C, and this side is C. Now if this angle is 90 degrees, this angle is also equal to 90 degrees. Now triangle ABD is also a right angle triangle. So in this triangle, Pythagoras theorem has to be valid. So C square has to be equal to A minus B cos C whole square plus B sin C whole square. That is equal to A square plus B square cos square C minus 2AB cos C plus B square sin square C. So B square cos square C plus B square sin square C. So these two terms combinedly become equal to B square, A square plus B square times sin square C plus cos square C is equal to 1 minus 2AB cos C. So the length of C square is equal to A square plus B square minus 2AB cos C. And if you interchange the terms, you can derive cos C is equal to A square plus B square minus C square by 2AB. So we can derive the formula of this type as well as the formula of this type. So once you can derive C square, similarly you can derive the formulas for B square as well as A square. If you drop the perpendicular onto side AC, you get the formula for B square. If you drop the perpendicular onto side C, so you get the other ratio. So in this way you can derive the cosine rule for a triangle. So let us see how questions will be asked on this. So now let us take this example. So in this question you're given that A plus B plus C times A minus B plus C is equal to 3AC. So if that is so, you're asked to find angle B. So A plus B plus C can be written as A plus C plus B times A plus C minus B is equal to 3AC. So if you take A plus C as an entity, so these are the form something plus something into something minus something, is something square minus something square. So this implies A plus C whole square minus B square is equal to 3AC. This implies A square plus C square plus 2AC minus B square is equal to 3AC. So if this 2AC goes onto that side, so plus 2AC goes onto that side becomes minus 2AC. So this implies A square plus C square minus B square is equal to AC. So if you divide both sides by 2AC, so A square plus C square minus B square by 2AC is equal to 1 by 2. So this implies this is nothing but the formula for cos B is equal to 1 by 2. This implies B is equal to 60 degrees. So the angle B by cosine rule can be found out as 60 degrees. So in this video, let us look at the projection rule in triangles. So the projection rule in triangle says that any side of a triangle is equal to the sum of projections of the other two sides onto this side. It means the side A is equal to the projection of C onto BC plus the projection of AC onto BC. Projection means the shadow. That is the vertical projection. So that means A is equal to, what is the projection of AB on BC? That's nothing but BD plus the projection of AC on BC is nothing but BC. So obviously the side A, which is equal to BC, has to be equal to BD plus DC, and that is equal to, what is BD? So if this angle is B, this angle is 90 degrees. So obviously cos B is equal to BD by C. So BD is equal to C times cos B plus, what is DC? So if this angle is C, what is cos C? Cos C is equal to DC adjacent side by hypotenuse is B. So DC is equal to B cos C. So in this triangle, the side A is equal to C cos B plus B cos C. So do you see the rhythm? C times cos of the other angle plus B times cos of the other angle. So A is equal to, so apart from A you have C and B. So the sides and angles have to be multiplied in a crisscross fashion. So A is equal to C cos B plus B cos C. So similarly you can also derive the formula for B, which is A cos C plus C cos A. So if you want B, the formula will be in terms of C and A. So if you want C, it will be A cos B plus B cos A. So these are the three formulas that you have regarding the projection rule. So the projection rule says that any side is equal to the sum of the projections of other two sides onto this side. So it's a very simple rule which you can apply. So let us take an example. So in this question you are asked to prove that A times B cos C minus C cos B is equal to B square minus C square. So let us see how you can solve this question. So by projection rule, A can be written as B cos C plus C cos B, right? So I can write A as this into B cos C minus C cos B. This is the LHS. So that is equal to, so this is of the form A plus B into A minus B. So we have B square cos square C minus C square cos square B. A square minus B square. So this can be written as B square times 1 minus sine square C minus C square times 1 minus sine square B. That is equal to B square minus C square. B square into 1 is B square. C square into 1 is C square. Minus B square sine square C plus C square sine square B. So you have B square minus C square plus C square sine square B minus B square sine square C. But I want the right hand side to be exactly B square minus C square. So I hope these two cancel each other. Yes, they cancel each other by sine rule. So from sine rule we know that B by sine B is equal to C by sine C. This implies B sine C has to be equal to C sine B. So if you square it on both sides, B square sine square C is equal to C square sine square B. So B square sine square C is exactly equal to C square sine square B. So one term has a plus, the other term has a minus. So these two get cancelled each other. So you have B square minus C square, which is the RHS. Hence LHS is equal to RHS, hence the result is proved. So in this question we have used both the projection rule as well as the sine rule. In this video let us look at the topic of half angle formulas. So there are formulas like sine A by 2 is equal to root of S minus B into S minus C by BC. Cos A by 2 is root of S into S minus A by BC. Tan A by 2 is root of S minus B into S minus C by S into S minus A. These formulas are called half angle formulas. So A is the angle of a triangle. Small a, small b, small c are the sides which we have already discussed. So how do we get these formulas? Sine A by 2 is equal to root of S minus B into S minus C by BC. So if you have sine A by 2 here, you get B and C here. So if you have B by 2, you get A and C. If you have C by 2, you get A and B. And whatever sides that come in the numerator, those sides come in the denominator also. So these formulas are based on the cosine rule which you have derived. So from trigonometry we know that sine square of A by 2 is nothing but 1 minus cos A by 2. 1 minus cos A is 2 sine square A by 2, or cos A is 1 minus 2 sine square A by 2. From this formula, so you can see that sine square A by 2 is 1 by 2 times 1 minus cos A. So from cosine formula, cos A is B square plus C square minus A square by 2BC. So that is equal to half times So if you take the LCM, you get 2BC minus B square minus C square plus A square by 2BC. That is equal to 1 by 4 BC times. So you can see this as equal to A square minus of, if you take a minus common from these three terms, you get B square plus C square minus 2BC. That is B minus C whole square. So that is equal to 1 by 4 BC times. This is of the form A square minus B square is nothing but A plus B into A minus B. That is A plus B minus C times A minus of B minus C, that is A minus B plus C. So that is equal to, so what is this term? These are very familiar terms in properties of triangles. So let us see what these terms are. There are two terms which are adding and one term which is getting subtracted. So we know that 2S is nothing but A plus B plus C. Because S is A plus B plus C by 2, 2S is A plus B plus C. Now what is 2S minus 2A? So let us subtract 2A from this 2S. Is nothing but A plus B plus C minus 2A. That is nothing but minus A plus B plus C. So if you have B plus C minus A, that's nothing but 2 times S minus A. Similarly, if you subtract 2B, 2 times S minus B will be equal to A minus B plus C. And 2 times S minus C is equal to A plus B minus C. So you need to remember these expressions very clearly. So whenever you have A plus B plus C, that is 2S. So if you have A plus B minus C, that's nothing but 2 times S minus C. A minus B plus C, 2 times S minus B, so on. So what is A plus B minus C? So that is equal to 1 by 4 BC times A plus B minus C is 2 times S minus C. This is 2 times S minus B. So 2, 2 and 4 gets cancelled. That is equal to S minus B times S minus C by BC. So sine square A by 2 is this. So sine A by 2 is square root of S minus B into S minus C by BC. So I hope this is a very straightforward derivation. So we just use the cosine rule here and we took the LCM and we have expressed this as A square minus B square. So it became A plus B into A minus B, and we have gone forward to derive this. So similarly, we can derive the formula for cos square A by 2 also. So cos square A by 2 is nothing but 1 plus cos A by 2. We have just one sign difference. So let us do the derivation for cos A by 2 also. So next, cos A by 2 is equal to, so the formula is 1 plus cos A by 2. That's nothing but half times 1 plus cos A is B square plus C square minus A square by 2BC. That is equal to half times, if you take the LCM, 2BC plus B square plus C square minus A square by 2BC. That is equal to half times B square plus C square plus 2BC is B plus C whole square minus A square by 2BC. That is equal to 1 by 4 BC times, this is also of the form A square minus B square. So A plus B into A minus B, B plus C plus A into B plus C minus A. So that is equal to, using the same derivations that we have done, B plus C plus A is nothing but 2S and B plus C minus A is nothing but 2 times S minus A by 4 BC. So 2 2s are 4 and 4 gets cancelled. That is equal to S times S minus A by BC. S times S minus A by BC. So cos A by 2, cos square A by 2 is 1 plus cos A by 2 is S into S minus A by BC. So cos A by 2 is root of S into S minus A by BC. And once you have sine A by 2 and cos A by 2, tan A by 2 is nothing but the quotient of these two, sine a by 2 by cos a by 2. So this BC and BC gets cancelled. So you get root of s minus b into s minus c by s into s minus a. So these formulas are called half angle formulas. So before moving forward, so we need to understand that these formulas are not just limited to a by 2. So if you want sine of b by 2, just need to take the square root of, if you're using b here, you should not use b here. That is s minus a into s minus c by ac. And what is sine c by 2? It's nothing but root of, you should not use c, so s minus a into s minus b by ab. So this is how you extend the formulas to other angles. So the derivation looks very similar. You can try to do the derivations. Similarly, cos b by 2 is nothing but, if you have a here, you have a here. So root of s into s minus b by ac. So in the denominator, whatever angle is used here, the corresponding side will not come. So what is cos c by 2? It's nothing but root of s times s minus c by ab. And once you have sine b by 2 and cos b by 2, tan b by 2 is nothing but root of s minus a times s minus c by s into s minus b, and tan c by 2 is equal to root of s minus a into s minus b by s into s minus c. So these are the complete set of half angle formulas which you need to understand. In this video, let us look at the various formulas that you have to calculate the area of a general triangle. So first, let us start with the very basic formula. Area is equal to, area of triangle is equal to half times base times height of the triangle. So half into base into the corresponding height of the triangle. So from this formula, we have three formulas to calculate area of a triangle. This half times, if you take a as the base, so you need to take the height corresponding to the vertex A, that is the altitude from A onto BC, that is HA. So this is also equal to half times, if you take B as the base, then you need to take the height corresponding to B as the height. That is equal to half times C times the height corresponding to vertex C. So you can use any of these formulas. To use these formulas, you need to know the base and the corresponding height. So this is the most basic formula for area of triangle. So now what are the other formulas that you have? So instead of base and height, so if the knowns are two adjacent sides, that is A, C and angle B. So if you know two adjacent sides and the included angle, can you find the area of this triangle? Yes. So let us see how we can do this. So area of triangle is equal to half times A into HA. In this case, HA is not known. Instead of that, angle B and C are known. So from these two, can you find HA? Yes, because this is 90 degrees. Sine B is equal to HA divided by hypotenuse C. This implies HA, height corresponding to the side A, is equal to C times sine B. So instead of HA, you can write C sine B. That is equal to half AC sine B. This is also a formula for area of triangle. That is half times the product of two adjacent sides into sine of angle between the sides. It's not necessary that you need to know only A and C and angle B. So area will also be equal to half AB times, if you have these two sides, you need to know this angle. So half times A into B times sine C is also the area of triangle, and this can also be written as half times BC times sine of A. So whatever two sides are known, you need to find you need to know the included angle between these two sides. And half into product of two sides into sine of included angle between those two sides is also area of a triangle. So this is the second set of formulas. This is the first set of formulas. This will be used when base and height are known. This will be used when two sides and the included angle is known. Now from this formula you can also create one more formula by using the sine rule. So we know that A by sine A is equal to B by sine B is equal to C by sine C is equal to 2R. So if you want to convert the whole formula in terms of sines, so A can be written as 2R sine A, C can be written as 2R sine C. So 2R times sine A into 2R times sine C into sine B by 2. So this is also the formula for area. So 1, 2 will get cancelled out. That is equal to 2R square times sine A, sine B and sine C. So area can also be written as 2R square sine A, sine B and sine C. So you know all the three angles and the circumradius, you can find the area. So this is the third formula to find the area of triangle. In the same way, you can convert this sine B in terms of sides. Sine B can be written as B by 2R. Sine B can be written as B by 2R. So delta can be written as, if you write this as B by 2R, ABC by 2 into 2R is 4R. So this is also the formula for area of triangle. So half into base into height, half AB sine C, 2R square sine A sine B sine C, delta is equal to ABC by 4R. And you have one more formula which can be used when you know all the three sides of a triangle. So half AC sine B, so from this half AC sine B can be written as 2 sine B by 2 cos B by 2. So this 2 and 2 gets cancelled. That is equal to AC times, what is sine B by 2 from half angle formulas, root of S minus A into S minus C by AC into root of S into S minus B by AC. So root AC into root AC is AC and AC gets cancelled. That is equal to root of S times S minus A times S minus B times S minus C. This looks like a very familiar formula for you. It's nothing but Heron's formula. So this is the derivation of Heron's formula. So if you want the area of triangle, if you know the sides of the triangle, you can use the formula semi-perimeter times S minus A into S minus B into S minus C square root. So this is the fifth formula for area of triangle. So half into base into height, half AC sine B, 2R square sine A sine B sine C, ABC by 4R, and Heron's formula root of S into S minus A into S minus B into S minus C. So you have one more formula which is very important, which is based on the inradius of the triangle. So if R is the inradius of the triangle, so delta can be written as inradius times S. Delta can be written as inradius times the semi-perimeter of the triangle. So the derivation of this will be covered in the topic of incenter and inradius. I am giving the formula here for the sake of completeness of the formulas of areas. So you have a total of 6 formulas to find the area of triangle. Depending on the information that you have, you can use appropriate formulas. So let us look at an example. So in this question, the area of the triangle is given as a square minus of b minus c whole square. If this condition is valid, what is the value of tan of A? So delta is equal to, this expression is of the form a square minus b square. That's nothing but a plus b minus c into a minus of b minus c is a minus b plus c. This implies delta is equal to, so we have already seen this expression a plus b minus c can be written as 2 times S minus C, and A minus B plus C is 2 times S minus B. So this implies delta square is equal to, so you have 4 square is 16 times S minus B whole square into S minus C whole square. So delta square is nothing but by Heron's formula, S into S minus A into S minus B into S minus C is equal to 16 times S minus B whole square into S minus C whole square. So 1 S minus B and S minus C are getting cancelled. This implies S into S minus A by S minus B times S minus C is equal to 16. So this is nothing but the reciprocal of tan A by 2, right? So this implies cot of A by 2 is equal to 16. This implies, this is cot square of, if you have square root, then it is cot A by 2. Cot square of A by 2 is equal to 16. So cot A by 2 is equal to 4. This implies tan A by 2 is equal to 1 by 4. So you want the value of tan A. From this information, you got the value of tan A by 2. So once you know this, can you find the value of tan A? Yes, using the multiple angle formulas. So we know that tan A is equal to 2 tan A by 2 by 1 minus tan square A by 2. That's equal to 2 times 1 by 4 by 1 minus 1 by 4 whole square is 1 by 16. That is equal to 2 times 4 by 15. 16 minus 1 is 15. That is equal to 8 by 15. So A is nothing but an angle whose tan is 8 by 15. This tan inverse of 8 by 15 is the answer. So in this example, you're asked to prove that A square sine 2B plus B square sine 2A is equal to 4 times area of the triangle. So let us start with LHS. So we know that A by sine A is equal to B by sine B is equal to C by sine C is equal to 2R. So A can be written as 2R times sine A. So A square can be written as 4R square times sine square A. So A square can be written as 4R square times sine square A times sine 2B can be written as 2 sine B cos B. Plus, similarly, B square can be written as 4R square sine square B times sine 2A can be written as 2 sine A cos A. That is equal to, so if you have 4R square as common, 2 is common, 1 sine A is common, and 1 sine B is also common. So you have 8R square sine A sine B if you take these as common. So 8R square 1 sine A 1 sine B if you take it as common. So you have sine A cos B plus cos A sine B. That is equal to 8R square sine A sine B times sine of A plus B. Sine of A plus B. And we know that A and B are angles of a triangle. So A plus B can be written as 180 minus C. That is equal to 8R square sine A sine B times sine of 180 degrees minus C. So sine 180 minus C is again equal to sine C. That is equal to 4 times 8 can be written as 4 times 2R square sine A sine B sine C, and 2R square sine A sine B sine C is one of the formulas for delta. So that is equal to 4 delta, which is the RHS, right hand side. Hence, the left hand side expression is exactly equal to the right hand side expression. Hence, this result is proved. In this section, let us look at the different centers and circles related to triangles. The first center that we are going to understand is the circumcenter, and the corresponding circle is the circumcircle. So circumcenter and circumcircle. So you would have already known what circumcenter and circumcircle is. A circumcircle is a circle which passes through all the three vertices of a triangle. So if ABC is a triangle, so the circle passing through all the three vertices of a triangle is called the circumcircle, and the center of the circumcircle is called the circumcenter and is usually denoted by the letter O. So if O is a circumcenter, obviously if I join O to the vertex B, the length of the line segment is equal to the radius of circumcircle. So usually denoted by capital R. So this is equal to capital R. So this should also be equal to capital R, and this length should also be equal to capital R. That means the circumcenter is equidistant from all vertices of triangle. Is the circumcircle is at equal distance from all the three vertices. So how do you find the circumcircle? The circumcircle can be found out as the point of intersection of the perpendicular bisectors of the sides. So if you take the perpendicular bisector of BC, that's the locus of points which are equidistant from B and C. So if you draw the perpendicular bisector of AB, those are the locus of points equidistant from A and B. So if you take the point of intersection of perpendicular bisectors, so the point of intersection will be equidistant from all the three vertices. So the circumcenter is nothing but the point of intersection of perpendicular bisectors. So the point of intersection of the perpendicular bisectors is called the circumcenter. Now, so what do you need to understand? What are the points that you need to understand about the circumcenter of a triangle? So the first thing that you need to understand is about the location of the circumcenter. So location of circumcenter. So in a acute angle triangle, the circumcenter lies inside the triangle. In a right angle triangle, the circumcenter lies at the midpoint of the hypotenuse. In an obtuse angle triangle, the circumcenter lies outside the triangle. So if you take an acute angle triangle, obviously the circumcenter has to lie inside the triangle. If you take a right angle triangle, because it's a right angle triangle and this is a circumcenter, so because this angle is 90 degrees, this has to be the diameter of the circle. And if this is the diameter, that means the hypotenuse has to be the diameter, and the midpoint of hypotenuse has to be the circumcenter. And if you take an obtuse angle triangle, the circumcenter should lie outside the triangle towards the hypotenuse side, towards the outside the hypotenuse. So the most important case for circumcircle and circumcenter is the right angle triangle. So in a right angle triangle, the circumcenter is the midpoint of hypotenuse. And that means from the midpoint of hypotenuse, if you join the right vertex, all the three lengths will be same. The distance of the midpoint of hypotenuse from the right vertex will be exactly equal to half of hypotenuse in all right angle triangles. So this is R, this is R, and this is R. So the first thing that you need to remember about circumcenter is the positioning of circumcenter. So for acute angle triangles, so the circumcenter lies inside the triangle. For right angle triangles, the circumcenter lies in the midpoint of hypotenuse. For obtuse angle triangles, the circumcenter lies outside the triangle towards the hypotenuse side. So once the location of circumcenter is clear, the other things that might be asked of you is, what is the distance of the circumcenter from the sides of the triangle? From the vertices, the distance of the circumcenter is equal to the circumradius. So what is this distance? If you are asked to find the distance of O from BC, that is from small a. If you are asked to find this distance, it's very easy to find. The first thing that you need to understand is BC makes an angle of A at the circumference. That means BC will make an angle of 2A at the center. And if you draw a perpendicular, this 2A will be divided into two parts, A and A. Now, triangle ODC is a right angle triangle, and cos A is equal to, cos of A is equal to adjacent side, which is the distance, by R. So the distance of the vertex the distance of the circumcenter from the side A can be written as R times cos of A. So the distance of the circumcenter from side AL, denoted by DA, is equal to R cos A. Similarly, the distance of the circumcenter from the side B. So if I want this distance, this is distance to the side B. So here AC makes an angle of B at the circumference. So it makes 2B at the center. So half of that will be equal to B. So cos B is equal to distance of B by radius. So distance B is equal to R cos B. And distance of the circumcenter from the side C is nothing but R cos C. Cos C. So this will be valid in any triangle. So in a right angle triangle, if I ask you to find the distance of circumcenter from the side A, so it will be R cos A. A is equal to 90 degrees. The distance will become 0. That means the distance of orthocenter from side BC is equal to 0. That means circumcenter lies on the side. So if you want the distance of orthocenter from side C, you can directly write it as R cos C, and this distance will be R cos B. So the same will be valid for obtuse angle triangles also. So these are the three things that you need to remember about circumcenter and circumcircles. First is, what is circumcircle and what is circumcenter, and about the location of circumcircle and circumcenter, and about the distance of circumcenter from the sides of the triangle. In this video, let us look at the topic of incenter and incircle of a triangle. So if you take ABC as a triangle, a circle which touches all the three sides of a triangle is called the incircle of the triangle ABC. Incircle touches all the sides of a triangle. That means the sides of a triangle are tangents to incircle. The sides are tangents to incircle. So that's the meaning of the incircle of a triangle. It touches all the three sides, or all the three sides will be tangents to the circle. Now, the center of this circle is called the incircle or incenter of this triangle. Now, what are the properties of this incenter? So this incenter is usually denoted by I. Now, as you can see, if the points where the incircle touches the three sides are P, Q and R, let this be the points of contact. Now, if I join IQ, do you see that this angle has to be 90 degrees? Why? Because the angle between the tangent and the radius at the point of contact is 90 degrees. So if I draw a perpendicular, or if I join IN, the point of contact, this angle will also be equal to 90 degrees, and this angle will also be equal to 90 degrees. And all these three sides will be equal to the radius of incircle smaller. So all the lengths of perpendicular are equal. That means incenter is a point whose lengths of perpendicular to all the three sides are equal. Or incenter is equidistant from sides of a triangle. Circumcenter is equidistant from the vertices of a triangle. Incenter is equidistant from the sides of the triangle. So now, how do I get the incenter? Incenter is the point of intersection of angular bisectors. Angular bisectors of angles A, B and C. This can be very easily proved because if you join BI, so if you take these two triangles, one angle is 90 degrees, right? These two triangles have one angle equal to 90 degrees. The hypotenuse is common for these two triangles and one of the side is same for these two triangles, both are R. And this triangle is congruent to this triangle, hence this angle has to be equal to this angle. Hence this has to be B by 2 and this has to be B by 2. That means the line joining the vertex with incenter has to be the angular bisector. Similarly, if I join this, here also you have C by 2 and C by 2. And if you join A to I, that will also be the angle bisector. So I is nothing but the point of intersection of angular bisectors of a triangle. So this will also be the angle bisector. And one more thing which you need to understand is this BI and IQ need not be collinear. This IQ is the perpendicular from I to side AC. This BI is the angle bisector. Angle bisector need not be always perpendicular to AC. So if you join the angle bisector, if you extend it, this need not follow the direction of IP. So let this be, so PQR, let this be S. So if you extend AI, it might cut the opposite side at another point other than P. So you should not confuse this, it should be this as equal to this. These two need not be equal. So once you have this basic understanding of incenter and incircle, so there are some special properties which you need to understand about this incenter and incircle. So let me write it one by one. So the first point which you need to understand is the concyclic property. So the point A, the point I and the foot of the perpendiculars R and Q. So these 4 points will always be concyclic. So A, Q, I, R. So these 4 points will be concyclic because if I draw a circle with AI as diameter, it will pass through R and Q because both these angles are 90 degrees. So the sum of opposite angles is 180, hence these are concyclic. Next, B, P, I, R, these 4 points are also concyclic, and Q, C, P, I, Q, C, P, I, Q, C, P, I, these 4 points are all concyclic. So AI, A, Q, I, R, B, P, I, R, C, Q, I, P are all concyclic points. So I hope you have understood why this is happening, because the sum of the opposite angles is equal to 180 degrees. So the second property which you need to understand about angle bisectors is the angle bisector theorem. So this theorem says that if ABC is a triangle and if AD is the angle bisector of angle A, then the ratio of BD by DC will be equal to AB by AC. The angle bisector divides the opposite side in the ratio of adjacent sides. BD by DC is equal to AB by AC. Similarly, if you have the next angle bisector, if you have the second angle bisector, again the ratio in which that bisector divides the opposite side is equal to the ratio of the adjacent sides. So on. So how do we prove this theorem? Why is this theorem holding? So this theorem is called angle bisector theorem, which you have already derived in your lower classes. So to prove this theorem, we use a theorem called basic proportionality theorem. So I hope you remember what basic proportionality theorem is, which states that if you have a triangle and if you have a line which is parallel to one of the base, so if you have a triangle ABC, if DE is parallel to BC, then AD by DB is equal to AE by AC. So that is called the basic proportionality theorem. And using that theorem, we'll try to prove the angle bisector theorem. So let ABC be the triangle and AD be the angle bisector. Now the construction that we do is, we draw a line from C parallel to AD to meet BA extended at the point E. Now according to basic proportionality theorem, these two are parallel, hence BD by DC is equal to BA by AE. So BD by DC is equal to BA by AE. Now what you need to prove is BD by DC is equal to BA by AC. You have BA by AE. So if you can prove that AC and AE are same, then this theorem will be proved. So now if you carefully observe this construction in triangle AEC, so these two are parallel sides, these two are parallel lines, and if you consider BE as the transversal, so this A by 2 is equal to this angle because these two are alternate angles, and this A by 2 is equal to this angle which is A by 2 because these two angles are corresponding angles. So these two angles are alternate angles, these two angles are corresponding angles, but these two are A by 2 and A by 2, hence these two angles are equal. Hence AE is equal to AC. AE is equal to AC, and once A is equal to AC, this implies BD by DC is equal to AB by AC. So this is a very standard theorem for angle bisectors, and this is called angle bisector theorem. So if you take angle bisector AD, BD by DC is equal to the ratio of sides on the same sides. That is BD, the same side is AB. So DC's side have AC on the side. So BD by DC is equal to AB by AC. So once you have this, can you find the length of BD and the length of DC? So obviously BC is A. BC is equal to A, and BD is nothing but this ratio. This is C and this is B. So the ratio is C is to B. So out of B plus C parts is BD. So BD is equal to C by B plus C times BC. That is CA by B plus C. So BD is equal to C by B plus C times this side, and DC is equal to B by B plus C times this total side, B by B plus C times A. So DC is equal to BA by B plus C, BD is equal to CA by B plus C. So in the same way, you can create the equations for the other angle bisectors also. So this is the second property of angle bisectors. So now let us go for the third property. So in the next property, let us see how area of the triangle is related to the inradius. So now if you take ABC as the triangle, let I be the incenter. We have already seen that the perpendicular distance of I from all the three sides will be equal to the radius of the incenter smaller. So if you draw the perpendiculars and if you join the three vertices with the incenter BI, AI and CI. Now what is the area of this triangle? So area of BIC, delta of BIC is equal to half times base BC can be called A times the height is nothing but smaller. The height is nothing but smaller. And what is delta BIA? What is the area of this triangle? So the area of this triangle is half times the base here is AB. So I can call it C times the height is again equal to R. because the perpendicular distance from I onto AB is R. What is delta of AIC? Half times AC times, that is B times R. So the area of this triangle is half times AB times R. Now if you add all these areas, you should get the total area. So the area of triangle ABC is equal to the sum of these three. So R by 2 times A plus B plus C. That is nothing but R times A plus B plus C by 2 is usually called S. So delta area of the triangle is also equal to R times S, or in radius of a triangle is equal to delta by S. So if you want the in radius, just need to divide delta by the semi-perimeter, and delta is equal to R into S. So these are the formulas connecting the area of triangle with the in radius. So the next formulas are the extension of R is equal to delta by S. So this is a formula which I have already derived, and from this you can also derive R is equal to S minus A times tan A by 2, or S minus B times tan B by 2, or S minus C times tan C by 2. And R is also equal to 4R sine A by 2, sine B by 2, sine C by 2. So these are very easy to derive using the half angle formulas which I have already known. So if you're asked to prove this, so S minus A times, what is the formula of tan A by 2? Root of S minus B into S minus C by S times S minus A. So this S minus A inside the root cancels one root S minus A, and root S minus A is remaining. So this is nothing but root of S minus A into S minus B into S minus C by root S. So if I multiply and divide with root S, so the denominator becomes S, and the numerator you have root of S into S minus A into S minus B into S minus C. It's nothing but delta by S. So S minus A times tan A by 2 is exactly equal to delta by S, which is again same as R. And similarly, if you just write the formulas for sine A by 2, sine B by 2 and sine C by 2, you'll see that everything will get cancelled out, and you again get 4R sine A by 2, sine B by 2, sine C by 2 is equal to delta by S. I encourage you to do this derivation by yourself. So the formulas for in radius are three types: delta by S, or S minus A tan A by 2, or S minus B tan B by 2, or S minus C tan C by 2, or 4R sine A by 2, sine B by 2, sine C by 2. So the next formula is regarding the distance of incenter from vertices. So if you have a triangle ABC, if I is the incenter, if I ask you the distance of this incenter from vertex A, so how do I get it? It's very simple. So if you join AI, we know that it bisects the side, it bisects the angle A, and if you draw a perpendicular from I onto AB or AC for that instance, this length of perpendicular will be equal to R, right? Now in this right angle triangle, what is sine A by 2? Sine A by 2 is equal to AI by R. So R, opposite side, by hypotenuse, R by AI. This implies AI is equal to R by sine A by 2, or the distance of incenter from the vertex A is nothing but R cosecant A by 2. So this is a general formula. If you want the distance of I from vertex B, BI will be equal to R cosecant B by 2, and CI will be equal to R cosecant C by 2. So the distance of the vertex from incenter can be very easily calculated by constructing this right angle triangle. So next, if you want the length of the complete angle bisector also, you can find it very easily. So how do I find it? So what is the area of triangle ABD? So triangle ABD area plus triangle ACD area is equal to area of triangle ABC, right? So what is the area of triangle ABD? So I am going to find the length of angle bisector. So I'll try to retain that angle bisector in the expression. So half into AB into AD times sine of A by 2. Half into product of two adjacent sides into sine of angle between them. So half times AB times AD times sine A by 2 plus, what is the area of this triangle? Half times AD times AC times sine A by 2 again is equal to, what is the area of the complete triangle ABC? Half times AB times AC times sine of angle A. So if these gets cancelled, and in these two terms AD sine A by 2 is common. So AD times sine A by 2, if you take it as common, AB is nothing but C, AC is nothing but B. So AB is nothing but C, AC is nothing but B. That is B plus C is equal to AB is nothing but C times AC is nothing but B times sine A. This implies AD is equal to, AD which is the angle bisector, is equal to BC into sine A is 2 sine A by 2 cos A by 2 divided by B plus C times sine A by 2. So sine A by 2 and sine A by 2 gets cancelled. This implies AD is equal to 2BC by B plus C times cos of A by 2. So the length of the angle bisector is 2BC by B plus C times cos of A by 2. This is the angle bisector of angle A. Similarly, if you want the angle bisector of angle B, BE is equal to, so if you want the angle bisector correspond to A, you have A here and the remaining two sides here. So if you want correspond to B, you have 2AC by A plus C times cos B by 2, so on. So if you want CF, 2AB by A plus B times cos C by 2. So we know the length of the bisector up to AI, and we know the total length also. From these two, we can find the ratio of distances AI is to ID also. So once we have the length of AI as well as length of AD, the next theorem that you have is the ratio of AI to ID will be equal to the sum of the sides by the opposite side. So AI is to ID is B plus C by A, or AI by ID is equal to B plus C by A plus B plus C. So both these theorems are same. If you do the component for this, you get this. AI by AI plus ID, which is equal to AD, is B plus C by B plus C plus A is A plus B plus C. So how do we prove this? We already have these two results. AI is equal to R cosecant A by 2, AD is equal to this. So let us see if the ratio of these two is exactly same as B plus C by A plus B plus C. So what is AI by AD? So R times cosecant A by 2 is nothing but R by sine A by 2 divided by 2BC by B plus C goes up into cos A by 2. That is nothing but R times B plus C divided by BC times 2 sine A by 2 cos A by 2 is sine A. Now half BC sine A is nothing but delta. So R times B plus C by BC sine A is 2 delta. Now we know that R is equal to delta by S, or R by delta is equal to 1 by S. So R by delta is 1 by S. So S comes in the denominator. So B plus C by 2S, which is B plus C by A plus B plus C. So AI by AD, the length of AI by the total angle bisector is the sum of the adjacent sides by sum of all the sides. Similarly, if you want just AI by ID, so you have the sum of the adjacent sides by opposite side is the answer. So these are the properties that you need to understand about the incenter. So in this video, let us look at what orthocenter is, and let us look at the properties of orthocenter. So first, what is orthocenter? Orthocenter is the point of concurrency of altitudes of a triangle. The point of concurrency of altitude of a triangle is called the orthocenter. That is, for example, if you have a triangle A, B, C. So first draw the altitude from the vertex A onto the opposite side. Altitude means the line which is perpendicular to BC. So from A, draw a height or altitude onto BC. Next, from B, draw an altitude onto AC. And from C, draw an altitude onto AB. So all of them will meet at a point called the orthocenter. It is usually denoted by the letter H. So orthocenter is usually denoted by the letter H. So now, what are the properties of orthocenter which you need to understand? So the first property is about the location of orthocenter. Location of orthocenter. So for an acute angle triangle, the orthocenter lies inside the triangle. So for an acute triangle, orthocenter lies inside the triangle. Now if you take a right angle triangle, so let us take a right angle triangle A, B, C. Let us take that this angle A is 90 degrees. Now what is the orthocenter of this right angle triangle? So to find the orthocenter, we need to draw the altitudes. So from C, if you draw the altitude, obviously altitude means a line perpendicular to AB. So this AC itself will be the altitude. The CA is perpendicular to AB. So this is one altitude. So what is the altitude from B? So the altitude from B is a line which is passing through B and perpendicular to AC, which is BA itself. So this is the next altitude. This is one altitude, this is the next altitude, and the third altitude is nothing but the line through A perpendicular to BC. So this is the third altitude. So where are all of these meeting? They are meeting at the point A. That is, for a right triangle, the orthocenter is the right vertex itself. The right vertex is the orthocenter. It's a very important property. Whenever questions on orthocenter is given, you need to check whether the question given contains a right angle triangle or not. If it contains a right angle triangle, you don't need to do anything. The right vertex will be the orthocenter of the triangle. And if you have an obtuse triangle, let us say that A, B, C. So let us say that angle A is obtuse. So how do the orthocenter look like? So if you draw the altitude from A, it will be like this. So if you extend it, this is the altitude. Now how does the altitude from B look like? So you cannot draw altitude like this because this angle is obtuse angle. So if you want to draw a perpendicular, it lies somewhere like this, right? The perpendicular looks like this. So these two tend to meet somewhere here. So if you draw the altitude from C onto AB, you need to extend AB and draw the altitude. So they are meeting outside the triangle. So for an obtuse angle, orthocenter lies outside the triangle. towards the obtuse angled vertex. Towards the obtuse angled vertex. We have seen that for obtuse angled triangle, the circumcenter also lies outside the triangle, but towards the hypotenuse side. The circumcenter lies on this side of the hypotenuse. The orthocenter lies on the side of the obtuse vertex. So I hope you understood the first point about the location of orthocenter. So let us go to the next point. For example, let us take the triangle ABC and H be the orthocenter of triangle ABC. H be the orthocenter of triangle ABC. So if H is the orthocenter of the triangle, now what we are going to say is, what is the orthocenter of triangle BHC? So what is the orthocenter of the triangle BHC? It is the triangle formed by two vertices of the original triangle and the orthocenter. So what is the orthocenter of this triangle? So how do we get the orthocenter? You need to draw the altitudes of this triangle. So from H, if you draw the altitude, that is same as AH. And what is the altitude from B onto HC? That is nothing but from B you need to draw a perpendicular onto HC. So obviously you cannot draw it inside. So you have to extend this outside, and this angle is 90 degrees. Hence BA is the next altitude. HA is one altitude. And what is the altitude from C onto BH? So you need to extend BH. Because this angle is 90, this angle is also equal to 90. So CA is the third altitude. And where are they meeting each other? They are meeting at the point A. So the orthocenter of triangle BHC is nothing but the point A. That is the remaining vertex. What is the orthocenter of triangle BHA? Orthocenter of triangle BHA is nothing but the vertex C. Right? If you have BHA, the orthocenter is nothing but the vertex C. So what is the orthocenter of triangle ACH? ACH. This is nothing but the point D. So this is a very frequent question which will be asked from the concept of orthocenter. So if H is the orthocenters of the triangle formed with the orthocenter and two vertices will be the remaining vertex. I hope you understood the second point. So now let us move on to the third point. So the third point that you need to remember is that the image of orthocenter with respect to any of the side of the triangle always lies on the circumcircle of the triangle. The image of orthocenter with respect to any side of triangle always lie on the circumcircle of the triangle. That means if you take the orthocenter, the image of orthocenter with respect to BC lies on the circumcircle somewhere, and the image of H with respect to AC, so if you take the image of H with respect to AC, that will also lie on the circumcircle of the triangle. And if I take the image of H about AB, so that will also lie on the circumcircle of the triangle. So this is the theorem. So how is this happening? So let us try to prove this theorem. So to prove this theorem, what I need to show is, so if this point is some S, so if I just show that HS will be equal to SP, then H will be the image of P, because it's already perpendicular, the line is already perpendicular. For the image, just this length has to be same as this length. So let us try to show that HS is equal to SP. So to show that, let us take a construction. Let us join BP. Let us join BP and let us take these two triangles. Let us take these two triangles. So in these two triangles, triangle BHS and triangle BSP, are there any things which are same in these two triangles? So this angle is 90, this angle is 90, both are 90s, and this side is common in both of this side is common. Next, are there any other things which are same in both these figures? So can I say that this angle is same as this angle? So let us see whether these two are same. So first, if you take this triangle B, so let us take this as T. So in triangle BTC, one angle is 90 degrees, the other angle is C. So this angle will be 90 minus C, right? 90. So these two combinedly has to be 90. So if this is C, this is 90 minus C. So angle HBC is nothing but 90 minus C. So is this angle also equal to 90 minus C? Let us see. So angle PBS is same as angle PBC. Angle PBS is same as angle PBC. Now angle PBC is the angle subtended by the chord PC on the segment of the circle. So PC also subtends this angle. This PC also subtends angle PAC on the circumference of the circle. So angle PBC has to be equal to angle PAC. Now what is this angle equal to? So what is this angle equal to? Let us take triangle in triangle ASC. In triangle ASC, angle S is equal to 90 degrees. One angle is C. The other angle has to be equal to 90 minus C. So angle angle SAC. SAC is equal to 90 minus C. So if SAC is equal to 90 minus C, angle PBC also equal to 90 minus C. So this is 90 minus C, this is 90 minus C. Hence, two angles are equal and the included side is same for these two triangles. Hence, these two triangles are congruent to each other. Triangle BSP is congruent to triangle BSH. So these two triangles are congruent, hence the corresponding sides are equal. HS is equal to SP. Hence the image of H about BC is nothing but P, which lies on the circumcircle of the triangle. Similarly, you can prove the other conditions also. So we can prove that H image about AB will be R and H image about AC will be equal to Q. So this is a very important property. The image of the orthocenter about any side of a triangle always lie on the circumcircle of the triangle. Let us try to calculate the distances of the vertices and the sides from orthocenter. So let ABC be the triangle and H be the orthocenter, which is the intersection of the three altitudes. For convenience, let us draw only two altitudes. So H is the orthocenter that you have. So what I am trying to calculate is the distance of H from the vertex A and the distance of H from the side BC. So I am trying to calculate AH and HD. AH and HD. So how do I do this? So first to calculate AH. So now let us try to see some angular properties in this figure. So in triangle ADC, this angle is 90 degrees. One angle is C. So what will this angle be? This angle will be 90 minus C. Is okay. Now in triangle AHE, this is also a right angle triangle. So if you want to go to AH, so let us take cos of 90 minus C is equal to cos theta is equal to adjacent side by hypotenuse AE by AH, right? Now what is AE? So AE can be found out from the triangle BEA. In triangle BEA, right? In triangle BEA, this is a right angle triangle. Angle E is equal to 90 degrees. Now if you take this total angle A, what is cos A? Cos A is equal to adjacent side AE divided by hypotenuse is nothing but the total side C. This implies AE is equal to C cos A. AE is equal to C times cos A. That's the cos component of this. We have seen this in projection rule also. So AE is equal to C cos A. We just need to put this here. So what is cos 90 minus C? Sin C is equal to C cos A divided by AH. And this implies AH is equal to C cos A by sin C. That is equal to, so what is C by sin C? C by sin C. From sine rule, A by sin A is equal to B by sin B is equal to C by sin C is equal to 2R. It is nothing but 2R cos A. So the length, the distance between the vertex and the orthocenter is nothing but 2R times cos A. So if you want the distance from vertex A, you need to put 2R cos A. Similarly, if you want the vertex, the distance from the orthocenter to vertex B, you need to do 2R cos B and 2R cos C. So once you have AH, so you can similarly derive BH is equal to 2R cos B and CH is equal to 2R cos C. Next, once you know the distance from the orthocenter to the vertices, can you find this distance? Can you find this distance? HD. So this is also quite simple, because what is BD? BD is nothing but C cos B. From the projection rule, BD is nothing but C cos B, because this angle is B. So C, the cos component is C cos B. Now once you know this, can you find this? What is this angle? This angle can be found out from this triangle. So in this triangle, one angle is 90, one angle is C. So this will be 90 minus C. So now which ratio will I use? Tan 90 minus C. Tan of 90 minus C is equal to HD by C cos B. HD by C cos B. This implies HD is equal to C cos B times tan 90 minus C is cot C. Cos C by sin C. And what is C by sin C? C by sin C is again 2R. So 2R cos B cos C. So HD is equal to 2R cos B cos C. 2R cos B cos C. What is AH? AH is 2R cos A. So if you want the distance from the vertex A, you need to write 2R cos A. If you want the distance from the side BC, the answer is 2R cos B cos C. So if you want the distance of this from side AC, you need to do 2R cos A cos C. So my HE will be equal to 2R cos A cos C. And what is H? F, if you want the distance here. So HF will be equal to 2R cos A cos B. So these are the distances of the orthocenter from the vertices and the sides. So these are the properties which you need to know about orthocenter. In this video, let us look at the topic of pedal triangle. So what is the pedal triangle for a given triangle? The triangle formed from the foot of the perpendiculars from the vertex onto the sides is called a pedal triangle. Is you draw the altitude from A onto BC, let the foot of the perpendicular be D. You draw the altitude from B onto AC, let the foot of the perpendicular be E, and let the foot of the perpendicular from C onto AB be F. The triangle DEF is called the pedal triangle of triangle ABC. So now, what are the things that you need to know about the pedal triangle? So the first thing that you need to understand about the pedal triangle is the orthocenter of triangle ABC, which is equal to H, the point of intersection of the altitudes. The orthocenter of the triangle ABC is nothing but the incenter of triangle DEF. Orthocenter of triangle ABC will be same as the incenter of the pedal triangle. And the second point which you need to understand is that the circumradius of the pedal triangle, the circumradius of pedal triangle is equal to the circumradius of triangle ABC by 2. The circumradius of triangle ABC divided by 2. That is, the circumradius of the pedal triangle will be exactly half of that of the circumradius of the original triangle. So these are the two things that you need to understand. So how do I get these two properties? This is what we're going to deal in this video. So to prove that H is the incenter of the pedal triangle, what I just need to prove is, I need to prove that this line DA is the angle bisector of angle D. That means I need to prove that this angle is equal to this angle. So if I can prove that the altitude of triangle ABC is the angle bisector of triangle DEF, then the point of intersection of altitudes of triangle ABC, which is the orthocenter, will be same as the point of intersection of the angle bisectors of triangle DEF, which is the incenter. So my aim is to prove that these two angles are same. So to do that, I'll use the angle properties which I have used in orthocenter. So first, what is this angle? This angle is nothing but, because this angle is 90, this angle is nothing but 90 minus A, right? Next, what is this angle? This angle is also equal to 90 minus A, because this angle is 90, this angle is A, so this angle is 90 minus A. Now, I'll use the first result, which is points B, F, H, D are concyclic. Can I say this? Points B, F, H, D are concyclic because the sum of angle BFH and BDFH is equal to 180 degrees. The angle this plus this angle is equal to 180 degrees. So because angle BFH plus angle BDH is equal to 180 degrees. 90 degrees plus 90 degrees is 180 degrees. So angle BFH plus BDH is equal to 180 degrees. Hence, you can draw a circle through these 4 points. You can draw a circle through these 4 points. And once you can draw a circle, so if you take FH as the chord, this chord subtends 90 minus A on the circumference and angle FDH also on the circumference. So angle FDH should be equal to angle FBH, which is equal to 90 minus A. So this angle FDH is equal to 90 minus A. Similarly, can I say that points DCEH are also concyclic? Yes, because this angle plus this angle is equal to 180 degrees. Hence, the sum of opposite angles is 180. Hence, these 4 points are concyclic. That means I can draw a circle through these 4 points also. I can draw a circle through those 4 points also. Now, if I take EH as the chord, so EH subtends an angle of 90 minus A on the circumference. So it has to subtend an angle of 90 minus A at D also. So angle HCE is equal to 90 minus A. This implies angle HDE is also equal to 90 minus A. So angle FDH is same as HDE. Angle FDH is same as HDE. Hence these two angles are same. Hence AD is the angle bisector. AD is the angle bisector. And this implies H is the incenter of triangle DEF. So that proves the first proposition. So next let us try to prove the second proposition, that the circumradius of the pedal triangle is half of the circumradius of the original triangle. So to find the circumradius of the pedal triangle, first I'll try to find the side of the pedal triangle. So I'll try to find the side EF. So to find the side EF, I use the cosine rule. So what is EF square? EF square is equal to AF square plus AE square minus 2 times AE times EF times cos of angle between the two sides. And what is AF? AF is nothing but B cos A. From projection rule, it is B cos A. And what is AE? AE is, from projection rule, C cos A. AE is C cos A. So EF square is equal to B square cos square A plus C square cos square A minus 2 times this side into this side BC cos square A times cos A. AF square plus AE square minus 2 times AF times AE times cos A. So that is equal to, so B square cos square A plus B square C square cos square A. So if you take cos square A as common, you get B square plus C square minus 2BC cos A. So what is B square plus C square minus 2BC cos A? That is nothing but the formula for A square. So this implies EF square is equal to A square cos square A, and this implies EF will be equal to A cos A. The length of EF will be equal to A times cos A. Now once you got the length of EF, so what is the circumradius of triangle DEF? That comes from the sine rule. Any side by sine of opposite angle is equal to 2 times the circumradius. So EF by sine of angle EDF is equal to 2 times the circumradius of the pedal triangle. A by sine A is equal to 2R. This implies what is EF? A cos A by what is sine of, what is angle EDF? We have already seen that this is 90 minus A, this is also equal to 90 minus A. So the sum of these two is 180 minus 2A. That is equal to 2R dash. This implies A cos A divided by sine 180 minus 2A is again sine 2A. That is 2 sine A cos A is equal to 2R dash. So these two gets cancelled. Now A by sine A is nothing but 2R of the original triangle. So 2R by 2 is equal to 2R dash. 2 and 2 gets cancelled. This implies R dash is equal to R by 2. That means the circumradius of the pedal triangle is equal to half of the circumradius of the original triangle. In this video, let us look at what centroid is, and we'll also look at some of the properties of this centroid. So now, the centroid of a triangle is the point of intersection of the medians of the triangle. And what is a median? A median is a line joining the vertex with the midpoint of the opposite side. So if you take the vertex A, the opposite side is the side BC. So if D is the midpoint of BC, then AD is the median. Similarly, B is the next median. B is the next median if E is the midpoint of AC. And the line joining C to the midpoint of AB, in this case denoted by F, is the third median. And the point of intersection of all these medians is called the centroid of the triangle. It is denoted by the letter G. And if you have a plate of the shape of a triangle, so the centroid turns out to be the center of gravity of the triangle also. So the centroid is also the center of gravity of the triangle. Now, what is the most basic property of the centroid that you need to understand? The centroid divides, G divides the median AD or BE or CF in the ratio 2:1, starting from vertex. This is the most important property of centroid. That is, if you take the median AD, G divides AD in the ratio 2:1. That means AG by GD is equal to BG by GE is equal to CG by GF is equal to 2:1. So the ratio is 2:1. So let us see why this property holds. So let us try to show that AG by GD is equal to 1. AG by GD is equal to 2:1. So to do that, let us take a construction. So the construction that I am going to do is, from D, draw a line parallel to B. From D, draw a line parallel to B. So once you do this construction, you can start deriving your result. So first, in triangle BCE, D is the midpoint of BC. D is the midpoint of BC, right? And D, if this point is H, if this point is H, so DH is parallel to B. DH is parallel to B. So from the converse of midpoint theorem, H should be the midpoint of EC. So this line is starting from the midpoint of one of the side and is going parallel to one of the side of the triangle. So it has to divide the other side into two equal parts. So from the converse of midpoint theorem, CH is equal to HE. So this is equal to this is equal to X, say. So let us say that this is X and this is X. Now we know that E is the midpoint of AC and EC is equal to 2X, hence AE is also equal to 2X. So if this is 2X, this is also equal to 2X. Now let us take this triangle ADH. So in triangle ADH, what can you see? So in triangle ADH, my GE is parallel to DH. GE is parallel to DH, right? GE is parallel to DH. So from basic proportionality theorem, what can you say? Because these two are parallel, from basic proportionality theorem, AG by GD is equal to AE by EH. AE by EH. And what is AE? 2X by EH is X. That is equal to 2:1. Hence AG by GD is equal to 2:1, which is the result which we need to prove. So similarly, you can also prove that BG by GE is equal to 2:1 and CG by GF is equal to 2:1. And this result works in the reverse also. That is, if you take the median and you plot the point which divides the median in the ratio 2:1, this point will automatically be the centroid. Centroid divides the median in the ratio 2:1, and the point which divides median in the ratio 2:1 is the centroid. So the property works both ways. Now let us go to the next property. So in the next property, let us look at the lengths of the medians and a theorem called Apollonius theorem. So first, if I have the triangle ABC whose sides are ABC, and if I draw the median AD, can I find the length of this median in terms of ABC? That's the question. So to do that, I'll try to use the cosine rule. I'll try to use the cosine rule in triangle ABD. So in triangle ABD. So what is cosine rule? AD square is equal to C square plus A square by 4. Right? AD square is equal to this square plus this square minus 2 times C times A by 2 times cos of angle B. This 2 and this 2 gets cancelled. That is equal to C square plus A square by 4 minus AC times. What is cos B? Cos B can be expressed in terms of ABC. Cos B is nothing but A square plus C square minus B square by 2AC. And this AC and this AC gets cancelled. That is equal to C square plus A square by 4. C square plus A square by 4 minus A square by 2 minus C square by 2 minus C square by 2 plus B square by 2. So C square minus C square by 2 is C square by 2. A square by 4 minus A square by 2. A square by 4 minus A square by 2 is minus A square by 4. If I take the LCM here, the LCM is 4. So we have 4C square plus A square minus 2A square minus 2C square plus 2B square. That is equal to 4C square minus 2C square is 2C square. A square minus 2A square is minus A square. So 2C square plus 2B square minus A square by 4. This is AD square. Hence, the length of median AD is equal to root of 2C square plus 2B square minus A square divided by 2. So if you want the length of AD, it's nothing but square root of 2B square plus 2C square. 2 times the squares of the adjacent sides minus the length of square of the length of opposite side by 2. So if you want BE similarly, if you want the median through B, if you want the length of this median BE, so that will be root of 2A square plus 2C square minus B square by 2. Similarly, if you want CF, CF will be equal to root of 2A square plus 2B square minus C square by 2. So this will give you the lengths of the medians of the triangle. So now once you have the medians of the triangle, you have something called Apollonius theorem, which says that AB square plus AC square, the sum of squares of two adjacent sides, AB square plus AC square, is equal to 2 times AD square plus BD square. AD square plus BD square. So this square plus this square, sum of squares of two adjacent sides, is equal to 2 times the median square plus BD square. Okay, so this will be this theorem is called Apollonius theorem. This is also a very important theorem in properties of triangles. So you can very easily derive this once you use the formula for AD square. So AB square plus AC square is nothing but B square plus C square. The LHS is B square plus C square. So the RHS is 2 times, what is AD square? AD square is 2c square plus 2b square minus a square by 4 plus BD square is nothing but a square by 4. So if you simplify this, you'll just get the value of d square plus c square. So 2 times plus 2 times a square by 4. 2 times AD square plus 2 times BD square. So as you can very clearly see, a square by 2 and a square by 2 is getting cancelled. So this 2 and 2 gets cancelled to give you d square plus c square here. So 4c square plus 4b square by 4 is b square plus c square. So the sum of squares of two adjacent sides is equal to 2 times the length of the square of the corresponding median plus the square of half the opposite side. So I hope you have understood the lengths of medians and Apollonius theorem. So let's go forward to the next property. So the next property which you need to remember about the centroid is that the centroid divides the line joining the orthocenter and circumcenter. In any triangle, the centroid divides the line segment joining orthocenter and circumcenter in the ratio 2:1. So the orthocenter, the centroid and circumcenter will always be collinear in any triangle, and the centroid divides OC in the ratio 2:1. That's the property. So how can I say this? So let us take ABC as a triangle. Let's draw the altitude AL, and on this altitude AL you have the orthocenter H, and let us draw the perpendicular bisector of BC. So D is the midpoint of BC and DC is perpendicular to BC, and on this you have the circumcenter. So let us say that H is the point of intersection of the altitudes which lie on AL, and C is the point of intersection of the perpendicular bisectors which lie on the perpendicular bisector DC. So now what you need to prove is that the centroid divides HC in the ratio 2:1, or you can also write this as O or H. Now to prove this, the construction that I do is I'll join AD. So let us join AD. So if I join AD, the construction looks like this. So let us say that the point where this AD cuts HC be equal to the point, let us call it point P. Now I'll do some derivation. So the observation that I do is AD is the median. AD is the median, right? AD is the median because D is the midpoint, A is the vertex, and CD is parallel to AL because CD and DL are perpendicular to the same transversal. So the altitude will always be parallel to the perpendicular bisector. Now in triangles AHP and triangle DCP, AHP and DCP, so can you see that this angle is equal to this angle? Angle HPA is equal to angle DPC. These two angles are vertically opposite angles, hence they are equal. Next, angle CDP is equal to angle HAP. So this angle is equal to this angle because they are alternate angles, because these two are parallel to each other. CD is parallel to AL, hence these two angles are alternate angles. So in these two triangles, two angles are equal, so automatically the third angle will be equal. Hence, these two triangles are similar to each other. Triangle AHP is similar to triangle DCP. And once the triangles are similar, the meaning is that the ratio of the sides is constant. So AH by CD is equal to HP by PC is equal to HP by PC is equal to AP by PD. But we know that AH is the distance between the orthocenter and the vertex. We have already derived this as 2r cos A. The distance between orthocenter and the vertex A is nothing but 2r cos A. We have already derived this. Next, what is the length of CD? CD is nothing but r cos A, right? We have done this derivation in the topic of sine rule. Just go through the derivation there. The distance between the circumcenter and the side is nothing but r cos A. So you can directly derive this by joining C to the vertex C. So this will be equal to r, and this angle will be exactly equal to A. So this will be r cos A. So for detailed derivation, go and see the derivation of sine rule. So r cos A, this is 2r cos A. So what is AH by CD? AH by CD is 2 by 1. That means HP by PC is also 2:1. And AP by PD is also 2:1. So now AP by PD is 2:1. That means this point P divides AD in the ratio 2:1. That means P should be exactly same as G, because the point which divides the median in the ratio 2:1 is nothing but the centroid. So this point will be the centroid of the triangle, and HP by PC will become HG by GC will be equal to 2:1. That's how we proved that the centroid divides the line segment joining orthocenter and circumcenter in the ratio 2:1. So OGC is 2:1. So these are the properties that you need to know about the centroid of the triangle. In this topic, let us look at the properties of a cyclic quadrilateral. So first, what is a cyclic quadrilateral? A cyclic quadrilateral is a quadrilateral which can be circumscribed by a circle. So not all quadrilaterals can be circumscribed by a circle. So if you take a general quadrilateral like this, so it's not necessary that it can be circumscribed by a circle, because if you take a quadrilateral, it can be divided into two triangles. It can be divided into two triangles. Now we know that if you take a triangle, there is only one and only one circle which passes through the three vertices of a triangle. That is, there exists only a unique circumcircle to the triangle. If I call it ABCD, so there is only one and only one circumcircle to the triangle ABD. So if you draw the circumcircle, the circumcircle is fixed. So if you draw the circumcircle, so it looks like something like this. So as you can clearly see, this circle is not passing through C. That means you cannot circumscribe all the four vertices of this quadrilateral by a circle, and this is not a cyclic quadrilateral. So a cyclic quadrilateral is a quadrilateral which can be circumscribed by a circle. So if you have a cyclic quadrilateral, what are the properties of the cyclic quadrilateral? The first and most important property is the sum of opposite angles of a cyclic quadrilateral is equal to 180 degrees. That is, angle A plus angle C is equal to 180 degrees, and angle B plus angle D is equal to 180 degrees. So if it is a cyclic quadrilateral, then the sum of opposite angles is 180 degrees, and vice versa also. That is, if the sum of opposite angles is 180, then the quadrilateral automatically becomes a cyclic quadrilateral. The next property is the sum of products of opposite sides of a cyclic quadrilateral is equal to the product of diagonals. That is AB times CD, the product of these two opposite sides, plus AD times BC, the sum of the products of opposite sides of a cyclic quadrilateral is equal to the product of the diagonals, that is AC times BD. AC times BD. So this is the second property of the cyclic quadrilateral. The third property of the cyclic quadrilateral regards to the finding the area of this quadrilateral. So if you have a cyclic quadrilateral, the area of this quadrilateral can be found by the formula S minus A into S minus B into S minus C into S minus D square root. Square root of S minus A into S minus B into S minus C into S minus D. That is, if you take the four sides as A, B, C, D. If you take the four sides as A, B, C, D, S is as usual the semi-perimeter. So S can be written as A plus B plus C plus D by 2. So if S is the semi-perimeter, the area of the cyclic quadrilateral can be given by root of S minus A into S minus B into S minus C into S minus D. So this is the third property of cyclic quadrilateral. And the next property of the cyclic quadrilateral is that if the sum of the opposite sides of the cyclic quadrilateral are equal, that is A plus C is equal to B plus D, the sum of A and C, if it is equal to sum of B plus B and D, then and only then you can inscribe a circle to this cyclic quadrilateral, within the cyclic quadrilateral. Then and if and only if A plus C is equal to B plus D, then an inscribed circle to quadrilateral ABCD is possible. So if I can inscribe a circle through this to the cyclic quadrilateral, then A plus C has to be equal to B plus D. And if A plus C is equal to B plus D, then a circle can be inscribed. So these are the four important properties of cyclic quadrilaterals which you need to understand. In this topic, let us look at how to find the circumradius and inradius of a regular polygon. So let us say that you have an n-sided regular polygon. N-sided regular polygon whose length of side is A. So let us say that the side is A units and C be the center of the regular polygon. So let C be the center of polygon. So now from C, join any two adjacent vertices of the regular polygon. That is, from C, join A and B, and also drop a perpendicular from C onto AB. Because it's a regular polygon, so whatever side you choose, you get the same measurements, right? Because the center of a regular polygon is symmetric with respect to each and every side of the polygon. So if C is the center and you choose one of the side AB as the base, so if you join CB and CA, both of these lengths will be same, and if you draw the perpendicular from C onto the base AB, so this length will be same for each and every side of the polygon. So let us take this as capital R and this as small r. Now if you take C as the center and draw a circle with radius R, if you take C as the center and draw a circle with radius R, so that circle will touch each and every side of the polygon, because the perpendicular distance of C from each of this side is equal to small r. So the circle with center C and radius small r will be the inscribed circle of the polygon. So r is the inradius of the polygon. Similarly, if you draw the circle with center C and radius capital R, because each of these vertex are at same distance from C, so that circle will be the circumcircle of the polygon. That circle will be the circumcircle of the n-sided regular polygon. So if you want the circumscribed radius of this n-sided polygon, you just need to find this distance. If you want the inscribed radius, you need to just find this length. So how do I find this length? That's very simple. So what will this angle be? So this angle will be total 360 degrees divided by n sides, because each side subtend same angle at the center, and there are n sides subtend n thetas, and the total angle is equal to 2 pi radians. So this angle ACB is equal to 2 pi by n. This angle is 2 pi by n. Now what is half of this angle? Because it is an isosceles triangle, the altitude will be also the angle bisector. So if this point is D, angle DCB is equal to 2 pi by n by 2 is pi by n. So this angle is pi by n. And because this total side is A, this is an isosceles triangle, the perpendicular will also be the median. So this dB will be equal to A by 2. It is the altitude will also be the median, so it divides the opposite side into two equal parts. Now you have the angle, you have a 90 degrees and you have a side. By using different ratios, you can find smaller and capital R. First, let us use the ratio tan pi by n. So tan pi by n is equal to opposite side by adjacent side. Opposite side is A by 2, adjacent side is R. This implies R is equal to A by 2 tan pi by n. That is equal to A by 2 cot pi by n. So small r, that is the inscribed radius of a n-sided regular polygon of side A, is A by 2 cot pi by n. Similarly, if you want capital R, we use the ratio sine. So sine pi by n is equal to opposite side by hypotenuse A by 2 capital R. This implies capital R is equal to A by 2 sine pi by n. If it goes to the numerator, it becomes cosecant pi by n. So capital R is equal to A by 2 cosecant pi by n, and small r is equal to A by 2 cot pi by n, where n is the number of sides and A is the side of the regular polygon. So this is how we derive the inscribed radius and the circumscribed radius of a regular polygon. So the ratio of the inradius to the circumradius. So if you want the radius of small r by capital R is equal to, so this A by 2 and A by 2 gets cancelled. Cot pi by n by cosecant pi by n. That is equal to, effectively this is cos by sine, this is 1 by sine. Sine and sine gets cancelled, is equal to cos pi by n. So the ratio of the inradius and circumradius of a regular polygon will be cos of pi by number of sides. For example, if the number of sides is equal to 3, so this will be cos pi by 3, which is equal to half. That means in a regular triangle, that is an equilateral triangle, small r by capital R is equal to 1:2. So if you take a four-sided regular polygon, which is a square, the ratio of small r to capital R is cos of pi by 4. This is 1 by root 2. Similarly, as n changes, the ratio of r by r changes, and as n goes larger and larger, this becomes cos of pi by a very large number. So this tends to cos 0, it tends to 1. That means as the number of sides increases, the value of small r goes very close to the value of capital R. Thank you. So this is what you need to understand about a regular polygon. So in this question, you're given that A1 is the area of the circle and A2 is the area of the inscribed pentagon in that circle. You're asked to find A1 is to A2. So you have a circle of radius is equal to R, and you have an inscribed pentagon inside this circle. So you're asked to find the ratio of the area of the circle to the area of the pentagon. So let us say that the radius of the circle be equal to R. So obviously A1, which is the area of the circle, is nothing but pi r square. Now, can I write the area of the pentagon in terms of R? So let us say that A is the side of this pentagon. Now, what is the area of the pentagon? Area of the pentagon is nothing but 5 times area of triangle OAB. So if you take any one side and join the side endpoints of the side with the center, you get a triangle, and you get 5 similar triangles, 5 equal triangles for correspond to each side of the pentagon. So area of the pentagon is 5 times the area of this triangle. So what is the area of this triangle? Area of this triangle is 5 equal triangles, 5 similar triangles for correspond to each side of the pentagon. So area of the pentagon is 5 times the area of this the side triangle. Area of this triangle is triangle 5 similar triangles for correspond 5 equal triangles to each side of the pentagon. So area of the pentagon is 5 times the area of this. So what is the area of this? The side triangle. Area of this triangle is triangle 5 similar triangles for correspond 5 equal triangles to each side of the pentagon. So area of the pentagon is 5 times the area of this the side triangle. Of this triangle is, so what is the area of this? For correspond 5 equal triangles to each side of the pentagon. So area of the pentagon is 5 times the area of this the side triangle. Of this triangle is, for correspond 5 equal triangles to each side of the pentagon. So what is the area of this? So area of the pentagon is 5 times the area of this the side of this triangle is triangle. For correspond 5 equal triangles to each side of the pentagon. So what is the area of this? So area of the pentagon is 5 times the area of this of this triangle is the side triangle. For correspond 5 equal triangles. So what is the area of this? So area of the pentagon is 5 times the area of this of this triangle is the side triangle. For correspond to each side of the pentagon. 5 equal triangles. So what is the area of this? So area of the pentagon is 5 times the area of this of this triangle is the side triangle. For correspond to each side of the pentagon. 5 equal triangles. So what is the area of this? So area of the pentagon is 5 times the area of this of this triangle is the side triangle for correspond to each side of the pentagon. 5 equal triangles. So what is the area of this? So area of the pentagon is 5 times the area of this triangle is the side triangle for correspond to each side of the pentagon. 5 equal triangles. So what is the area of this? So area of the pentagon is 5 times the area of this triangle is the side triangle for correspond to each side of the pentagon. 5 equal triangles. So what is the area of this? So area of the pentagon is 5 times the area of this triangle is the side triangle for correspond to each side of the pentagon. 5 equal triangles. So what is the area of this? So area of the pentagon is 5 times the area of this triangle is the side triangle for correspond to each side of the pentagon. 5 equal triangles. So what is the area of this? So area of the pentagon, the area of this triangle is the side triangle for correspond 5 equal triangles. So what is the area of this? So area of the pentagon to each side of the pentagon. The area of this triangle is triangle for correspond 5 equal triangles. So what is the area of this? So area of the pentagon, the side to each side of the pentagon. The area of this triangle is triangle for correspond 5 equal triangles. So what is the area of this? The side to each side of the pentagon. The area of this triangle is triangle for correspond 5 equal triangles. The side to each side of the pentagon. The area of this triangle is triangle. So what is the area of this? For correspond 5 equal triangles. This point D will be possible within the triangle. So what I do is, I'll do some construction. I'll join D with each of the vertices. I'll join D with each of the vertices. Now I got 3 triangles. Let us take the first triangle. So what is the area of this triangle? So A, let us call this A1 is equal to half into base is A into this 4 will become the height of this triangle, right? And if you take the next triangle, if you take this triangle, A2 should be equal to half times A times 5. Half times A times 5. And if you have A3 is, let us consider this area as A3. So A3 will be equal to half times A times 6. Now if you add all these areas, you should get the total area. So the total area of the triangle, which is root 3 by 4a square, because it is an equilateral triangle, we know that the formula is root 3 by 4a square, should be same as sum of these 3. It is half a times 4 plus 5 plus 6. So these two have to be exactly same. By equating these two, 1a gets cancelled. So A will be equal to, so this 2 and this 2 gets cancelled. So 2 by root 3 times 4 plus 6 is 10 plus 5 is 15. That is equal to, so if you cancel this root 3 out, you get 10 root 3 as the answer. So if a point D such that these distances are valid, then the side of the equilateral triangle has to be equal to 10 root 3. Now once you got this side of the triangle, you can easily find the area. So area is equal to root 3 by 4 times a square is nothing but 3 times 100. So 25, so that's equal to 75 root 3 square units. So this will be the required area of the triangle. So in this question, you're given that the sides of a triangle are 6, 7 and 8. And the line through the incenter parallel to the shortest side meets the other sides at P and Q. If that is so, what is the length of PQ? So you're given that you have a triangle whose sides are 6, 7 and 8. It's a scalene triangle. So let us say this length is equal to 6, this length is equal to 7 and this length is equal to 8. Now you take the incenter of this triangle. So let us take this as the incenter, somewhere inside the triangle. So let us call this triangle as ABC. So a line through the incenter parallel to the shortest side, which is equal to 6. So if I draw a line parallel to this, parallel to the side BC through the incenter, it's given that it meets the other two sides at P and Q. So if that is so, what is the length of PQ? That's the question. Now, so what can I do here? So first what I do is, I'll draw a perpendicular from incenter to the side BC. And this will be equal to the inradius of this triangle, right? And next I'll draw an altitude from A onto BC. If I draw an altitude from A onto BC, this will be the height corresponding to BC. So let us call this HA, the height corresponding to BC. Now, can I find the value of RS? Can I find the value of HA? Yes, I have standard formulas to do that. So small r will be equal to delta by S. Small r will be equal to delta by S. This is the formula of incenter. And what is HA? Delta can be written as half times 6 times HA. The area of this triangle is half into 6 into HA. So this gets cancelled 3 times. So height corresponding to A can be written as delta by 3. So now if you carefully observe this diagram, can you see that the triangle APQ and ABC are similar to each other? Triangle APQ is similar to triangle ABC because these two lines are parallel to each other, and this angle is same as this angle and this angle will be same as this angle, and angle A is common. All the angles of this triangle are same as the angles of this triangle. Hence these two triangles are similar to each other. So now once they are similar to each other, the ratio of their sides is same as the ratio of their heights. So the ratio of their sides, which is PQ by BC, I'm not writing all the sides, I don't require all the sides. So PQ by BC is same as the height of this small triangle by the height of this big triangle. So what is the height of this small triangle? HA minus R. The total height is H. This length is R. So HA minus R is the height of the small triangle divided by height of the total triangle is HA. And this implies what is PQ by BC. PQ is unknown here. BC is 6 is equal to 1 minus R by HA. And R by HA can be found out from this. So R by HA is equal to delta and delta gets cancelled. you get 3 by s. And what is s? S is a semi-perimeter. S is equal to 6 plus 7 plus 8 by 2, which is equal to 21 by 2. So if you put 21 by 2 here into 2, that is equal to 2 out of 7. 2 out of 7. So R by HA is 2 out of 7. If you just put that, 1 minus 2 by 7 is equal to 5 by 7. And PQ is equal to 30 by 7 units. So that will be the length of PQ. So in this question, you're given that the ratio of the sides of a triangle is 3:7:8. So if that is so, you're asked to find the ratio of circumradius to inradius. So how do we do this? We know the basic formulas for capital R and small r in terms of ABC. So small r is equal to delta by S, and capital R can be written as ABC by 4 delta, because delta is equal to ABC by 4 capital R. R can be written as ABC by 4 delta. So capital R is to small r is equal to ABC by 4 delta square times S. So if I can find this value, then I get the ratio of capital R by small r. A is to B is to C is given. So I can take A is equal to some 3x, B is equal to some 7x, and C is equal to 8x, right? Because that's the ratio in which A, B, C are there. So now once I know A, B and C, I can as well find the value of S as well as delta. So delta can be found using the Heron's formula. So to find that, first let us find S. S is nothing but the semi-perimeter. 3x plus 7x plus 18x by 2. 3x plus 7x plus 8x by 2, that is equal to 9x. So S is equal to 9x. So we have ABC, that is 3x into 7x into 8x times S is 9x divided by 4 times delta square is nothing but S times S minus A times S minus B times S minus C. So S is 9x times S minus A, you have 6x, into S minus B, you have 2x, into S minus C, you have x. So this is ABC into S by 4 times delta square. So now cancel out the terms which are common in numerator and denominator. So 9x and 9x are getting cancelled. So all the x's gets cancelled, as you can see. All the x's gets cancelled. So 3 2s are 6, and 4 and 2 gets cancelled with 8. So you are finally left out with 7 by 2. So capital R by small r will be equal to 7 by 2. So in this question, you're given that delta is equal to A square plus B square minus C square. If that is so, you're asked to find the value of tan C. So how do we do this? So let us try to analyze tan C. So tan C is nothing but sine C by cos C. You need to find this. And sine C can be written as, so we know from sine rule that A by sine A is equal to B by sine B is equal to C by sine C is equal to 2R. This is sine rule. So what can I write sine C as? Sine C can be written as C by 2R. This is C by 2R times what is cos C? From cosine rule, we have A square plus B square minus C square by 2AB. So this 2AB goes into the numerator. You have 2AB. So this 2 and this 2 gets cancelled. So you get ABC by R times A square plus B square minus C square. That means if you want tan C, you need to effectively find this. Now what is the given information? The given information is delta is equal to A square plus B square minus C square. And what is the formula for delta in terms of capital R? Because tan C is in terms of A, B, C and R, and A square plus B square minus C square. So we know that the formula for delta is ABC by 4 times capital R is equal to A square plus B square minus C square. So this implies I need to find this. So what I do is A, B, C by 4 times A square plus B square minus C square times R is equal to 1. So A, B, C by R times A square plus B square minus C square, if you cross multiply this, so will be equal to 4. So this will be the value of tan C. So in this question, you're asked to prove that A plus B plus C times B plus C minus A times C plus A minus B times A plus B minus C by 4B square C square is equal to sine square A. So let us start from the LHS. So the expressions that you have in the numerator are very standard expressions. A plus B plus C is nothing but 2S. B plus C minus A is 2 times S minus A into 2 times S minus B into 2 times S minus C by 4B square C square. That is equal to, so if you take these 2's outside, you have 16 S into S minus A into S minus B into S minus C. From Heron's formula, this is delta square by 4B square C square. And if you cancel this out 4 times, that is equal to 4 times, what is delta square? So one of the formula for delta square or delta is half BC sine A. So delta square is a whole square by B square C square. So you should understand why I have written only this formula, because finally I want sine square in the RHS. It means B square and C square has to get cancelled out. So I'll write a formula where B square C square can be cancelled out. That is equal to 4 times 1/4 B square C square sine square A divided by B square C square. 4 and 4 are getting cancelled. B square C square and B square C square are getting cancelled. So is equal to sine square A, which is the RHS, hence proved. So in this question, you're asked to prove that R1 plus R2 plus R3 minus R is equal to 4 times capital R. So how do we try to do this? Let us start with our LHS and see whether it leads to RHS. So I'll substitute the basic formulas for these expressions, these terms. R1 is delta by S minus A plus delta by S minus B plus delta by S minus C minus delta by S. That is equal to, so now if you take delta as common, you have 1 by S minus A plus 1 by S minus B plus 1 by S minus C minus 1 by S. Now, so if you try to simplify all the 4 terms at once, it will be a hectic task because you have 4 terms. You need to take LCM of all the 4 terms. So first what I do is I'll club two terms. So let us club these 2 terms. So what is 1 by S minus A plus 1 by S minus B? If you take the LCM, you get S minus A times S minus B. And in the numerator, you have S minus B plus S minus A, that is 2S minus of A plus B. Plus, what is the sum of these two? S times S minus C. So S minus of S minus C. That is equal to delta times 2S is A plus B plus C. Minus of A plus B is C by S minus A times S minus B. Plus S minus of S minus C, S and S gets cancelled. So you get again C by S times S minus C. So this C can be taken as common. So you get C delta times 1 by S minus A times S minus B plus 1 by S times S minus C. Now let us take LCM and see what happens. That is equal to delta times C times the denominator. The LCM is S into S minus A into S minus B into S minus C. And if you take the LCM, you get S times S minus C minus plus S minus A times S minus B. So the denominator is delta square, right? The denominator is delta square. You get C by delta times. So let us try to simplify this. S square plus S square, you have 2S square minus CS minus AS minus BS, that is minus of A plus B plus C times S plus AB. So these are the terms that you have. And A plus B plus C is nothing but 2S. So you get 2S square minus 2S square. These two terms are getting cancelled. So you're getting ABC by delta. And I can write as into 4 by 4. And ABC by 4 delta is nothing but capital R. So you get 4 times capital R, which is the RHS. So in this question, you're asked to prove that cos A plus cos B plus cos C is equal to 1 plus small r by capital R. So first remember the formulas for small r. You have small r as 4r sine A by 2 sine B by 2 sine C by 2, right? So in the LHS, in the RHS, you have 1 plus 4r sine A by 2 sine B by 2 sine C by 2 by r and r gets cancelled. So effectively it is 1 plus 4 sine A by 2 sine B by 2 sine C by 2. And once you see the LHS and the RHS, do you see some relation between them? So I can see the relation in the topic of conditional identities. So we know that A plus B plus C is equal to 180 degrees because we are dealing with triangles. So A plus B plus C is equal to 180 degrees. This implies cos A plus cos B plus cos C is equal to 1 plus 4 sine A by 2 sine B by 2 sine C by 2. We have derived this in the topic of conditional identities. So I just use this formula here. So that is equal to 1 plus, I'll multiply and divide the second term with capital R. 4r sine A by 2 sine B by 2 sine C by 2 by capital R, that is equal to 1 plus 4r sine A by 2 sine B by 2 sine C by 2 is small r by capital R. So cos A plus cos B plus cos C is 1 plus small r by capital R. Hence, the proposition is proved. So in this question, you're asked to prove that A cos A plus B cos B plus C cos C by A plus B plus C is small r by capital R. So as we have seen in the previous question, small r by capital R is nothing but 4 sine A by 2 sine B by 2 sine C by 2. So if I can prove that the LHS is also the same expression, then my statement is proved. So to do that, what I do is I'll use my sine rule first in the numerator. So A can be written as 2r sine A, B can be written as 2r sine B, C can be written as 2r sine C. So you get 2r sine A cos A plus 2r sine B cos B plus 2r sine C cos C divided by, in the denominator also you have 2r sine A plus 2r sine B plus 2r sine C in brackets. Now if you have an r in the numerator and also in the denominator, it gets cancelled out. So r can be cancelled out. Now 2 sine A cos A is sine 2A. So you have sine 2A plus sine 2B plus sine 2C divided by 2 times sine A plus sine B plus sine C. Again, remember the conditional identities that we have derived. So this is equal to, so sine 2A plus sine 2B plus sine 2C, in the denominator you have sine A plus sine B plus sine C. Just try to remember the conditional identities that we have derived. If A plus B plus C is equal to 180 degrees, sine 2A plus sine 2B plus sine 2C is 4 sine A sine B sine C divided by 2 times sine A plus sine B plus sine C we have derived in the conditional identities, that is equal to 4 times cos A by 2 cos B by 2 cos C by 2. So you can very easily derive this using the transformation formulas. So that is equal to 4 and 4 gets cancelled. So sine A is 2 sine A by 2 cos A by 2 into 2 sine B by 2 cos B by 2 into 2 sine C by 2 cos C by 2 divided by 2 times cos A by 2 cos B by 2 cos C by 2. So cos A by 2 cos B by 2 cos C by 2 gets cancelled. So 1 2 gets cancelled. So you have 2 2's remaining, that is 4 sine A by 2 sine B by 2 sine C by 2, which is equal to small r by capital R. Hence the proposition is proved. So in this question you're given that R1 is less than R2 is less than R3. If this is so, find the order of the sides of the triangle. Second, this can be very easily done using the basic formula. So R1 is nothing but delta by S minus A is less than delta by S minus B is less than delta by S minus C. So all the quantities are positive. So if I reciprocate all this, the signs of the inequality reverses. And delta can be cancelled out on all the sides. So S minus A is greater than S minus B is greater than S minus C. So minus A is greater than minus B is greater than minus C. So if I again multiply it with a minus, so again the sign reverses. So A is less than B is less than C. So if R1 is less than R2 is less than R3, correspondingly A will be less than B will be less than C. So this will be the answer to this question. So in this question, given that the sides of the triangle are 18, 24 and 30, we are asked to find the value of Inradius. So again a very straightforward question. We know that Inradius is nothing but delta by S. Delta is the area, S is the semi-perimeter. And delta in turn can be found using Heron's formula if you have all three sides. So delta is equal to root of S times S minus A into S minus B into S minus C. And S is nothing but the semi-perimeter, that is 18 plus 24 plus 30 by 2. So that is 72 by 2 is 36. So S is 36. So delta is root of 36 into 36 minus 18 is 18 into 36 minus 24 is 12 into 36 minus 30 is 6. That is equal to, so 36 comes out as 6. So this is 6 into 2. So we have 2 6s, one more 6 comes out, into 18 2s are 36, one more 6 comes out. That is equal to 216. So delta is equal to 216 or 6 into 6 into 6. So the value of small r is equal to delta, which is 6 into 6 into 6 divided by S is a semi-perimeter, which is 36. So 2 6s gets cancelled. So 6 units is the right answer to this question. So in this question, you're given that A minus B times S minus C is equal to B minus C times S minus A. And if that is so, you're asked to prove that R1, R2, R3 are in AP. So let us see how we can simplify this. So A minus B by S minus A is equal to B minus C by S minus C. Right? Now let us try to simplify these terms A minus B and B minus C. So now how can I write A minus B as? A minus B can be written as S minus B minus of S minus A. So let us see whether this is valid or not. What is S minus B minus of S minus A? S is getting cancelled, S and minuses gets cancelled. So minus B plus A is nothing but A minus B. So A minus B can be written as S minus B minus of S minus A. Similarly, B minus C can be written as S minus C minus of S minus B. So these are the two simplifications that I am going to use in this question. So this implies A minus B can be written as S minus B minus of S minus A by S minus A is equal to S minus C minus of S minus B divided by S minus C. That is equal to S minus B by S minus A. S minus B by S minus A. What is S minus B by S minus A? Delta 2 is equal to, R2 is equal to delta by S minus B. R1 is equal to delta by S minus A. So S minus B by S minus A can be written as R1 by R2. So can you see this? R1 by R2 is
denominator you get s minus a, in the numerator you get s minus b. So s minus b by s minus a can be written as r1 by r2 minus 1 is equal to s minus c by s minus c is 1 minus s minus b by s minus c can be written as r3 by r2. So this implies so if r3 by r2 comes on this side, r1 by r2 plus r3 by r2 is equal to 1 plus 1 is 2. This implies r1 plus r3 is equal to 2r2. This implies r1, r2 and r3 are in arithmetic progression. So in this question, the critical thing that you need to see is this simplification. A minus b can be written as s minus b times s minus a. B minus c can be written as s minus c minus of s minus b. So if you can think of this manipulation, then the remaining question is quite easy. In this question, you're given that in a triangle, the side A is less than or equal to side B is less than or equal to side C. C is the largest side of the triangle. And C square is greater than A square plus B square. In that case, you're asked to prove that the triangle is obtuse. So let us use the cosine formula. Obviously, C is the largest side. So if at all this triangle is obtuse angled, so the obtuse angle will be angle C, because the angle opposite to the largest side is the largest. So C is the largest side. So the angle opposite to C, which is angle C, will be the largest angle. So what is cos C? Cos of angle C by cosine rule is nothing but A square plus B square minus C square by 2AB. But according to the given condition, A square plus B square minus C square is less than 0. That means the numerator is negative. The denominator is obviously positive because these two are lengths. So this implies cos C is negative. This implies C is obtuse. So angle C of this triangle is obtuse, hence this triangle is a obtuse angle triangle. So in this question, we're given that in a triangle ABC, 1 by A plus C plus 1 by B plus C is equal to 3 by A plus B plus C. So if this condition is valid, so you need to prove that angle C of the triangle is 60 degrees. So let us try to simplify this condition. Let us try to see if this condition leads to some information about angle C. So if you take the LCM, you have B plus C plus A plus C divided by A plus C times B plus C is equal to 3 by A plus B plus C. So if you do the cross multiplication, you get A plus B plus C times, you have A plus B plus C plus C. You have A plus B plus C plus another C is equal to 3 times A plus C times B plus C. So this implies you have, if you expand the bracket in this way, A plus B plus C into A plus B plus C. So you have A plus B plus C whole square plus C times A plus B plus C is equal to 3 times, if you multiply these two, you get AB plus BC plus CA plus C square. So this implies, what is A plus B plus C whole square? You have A square plus B square plus C square plus 2AB plus 2BC plus 2CA plus you have an AC again, you have a BC again, you have a C square again is equal to 3AB plus 3BC plus 3CA plus 3C square. So is there any term that is getting cancelled? Let us see. So you have 2BC plus BC, 3BC and 3BC are getting cancelled. Next, 2AC plus AC is 3AC and 3AC gets cancelled. You have 2C square here. So C square and C square is 2C square. So if you cancel it out, you have an extra C square which is remaining here. So you have 2AB here. So if 2AB gets cancelled out, you have an AB here. So effectively you got A square plus B square is equal to C square plus AB. This implies a square plus b square minus c square is equal to ab. And this implies a square plus b square minus c square by ab is equal to 1. Does this formula remind you of some rule? Yes, this looks like cosine rule for angle C. So you have an extra 2 here. So I am multiplying and dividing with 2. This is nothing but cos of C, right? A square plus b square minus c square by 2ab is cos of C. And that is equal to half. This implies C is equal to 60 degrees. Hence, the proposition is proved. Thank you. In this question, given that in a triangle ABC, a square, b square and c square are in arithmetic progression. And you need to prove that cot A, cot B and cot C are also in arithmetic progression. So let us first try to analyze what we need to prove. So we need to prove that cot A, cot B, cot C are in AP. So let us try to see what cot A is in terms of a square, b square, c square. Because given information is in terms of a square, b square, c square. So what is cot A? Cot A is nothing but cos A by sine A, right? That is equal to what is cos A? B square plus c square minus a square by 2bc into sine A, sine of capital A. So what I do is I'll multiply and divide this expression with A. So if I have an A in the numerator and an A in the denominator. So this becomes equal to b square plus c square minus a square by 2abc times A by sine A is nothing but 2r. So this 2 and this 2 gets cancelled. So cot A is effectively capital R by ABC times b square plus c square minus a square. Cot A in terms of ABC is this. So similarly, if you do the same derivation for cot B can be proved as R by ABC using symmetry. So because if you have A, you have a minus a square. So if you have a B, you have a square plus c square minus b square. And cot C will be equal to R by ABC times a square plus b square minus c square. So now what you need to prove is that these three are in AP. So if these three are in AP, you need to effectively prove that these three terms are in AP. But R by ABC is a constant present in all these terms. So from the properties of arithmetic progression, if you prove that these three terms are in AP, it will automatically prove that some constant times these three terms are also in AP. So effectively, your aim now is to prove that these three terms are in AP. So I'll try to do that. I'll start with the given information and try to prove that these things happen. So what I do is I'll start with, given that a square, b square, c square are in AP, this implies 2a square, 2b square, 2c square are also in AP. Because if I uniformly multiply all these terms with a given term, the AP does not change. So this implies I'll subtract a square plus b square plus c square from each of these terms. So 2a square minus of a square plus b square plus c square, comma 2b square minus of a square plus b square plus c square, comma 2c square minus of a square plus b square plus c square are also in AP. So I am subtracting a constant term uniformly. So this implies, what is this? 2a square minus a square is a square minus b square minus c square, comma what is this? This is minus a square plus b square minus c square, comma this is minus a square minus b square plus c square are in AP. Now I'll uniformly multiply each of this term with a minus 1. So that implies b square plus c square minus a square plus c square minus b square, a square plus b square minus c square are in AP. So if these are in AP, if you multiply each of this by R by ABC, those are also in AP. Hence cot A, cot B chord C are in AP. Hence, we prove the result. So in this question, given that in a triangle ABC, angle A is equal to 120 degrees and BC plus CA is equal to 20, AB plus BC is equal to 21. So with these three informations, can you find the length of BC? So let us try to use each of these informations. If you draw the diagram corresponding to this, it looks something like this. Angle A is equal to 120 degrees. BC is nothing but A plus CA is nothing but B is equal to 20. C plus A is equal to 21. You're asked to find the value of A. And angle A is equal to 120. Now, angle A is equal to 120. Let me use this information with respect to cosine rule. So cos A is equal to cos of 120 degrees is equal to B square plus C square minus A square by 2BC. And cos 120 is minus 1 by 2. So that is equal to minus 1 by 2. This 2 and this 2 gets cancelled. So if you cross multiply this, you get B square plus C square minus A square is equal to minus BC. This implies B square plus C square plus BC is equal to A square. So let us keep this information with us. We're asked to find the value of A. So A has been written in terms of B and C. Now, from these informations, what is B? B is nothing but 20 minus A. So from this information, B is 20 minus A. And from this information, C is 21 minus A. So can I use these two informations in this expression? So B square plus C square plus BC. So can be written as this implies. So if I have to use this slightly intelligently, I can just substitute B as 20 minus A and C as 21 minus A and expand this. But the better way is, so I can write this as B minus C whole square plus 3BC is equal to A square. So B minus C whole square is B square plus C square minus 2BC plus 3BC is plus BC. Now what is B minus C? If you subtract one from the other, B minus C is equal to 20 minus 21 is minus 1. So B minus C is minus 1. So B minus C whole square is 1. So this completely becomes 1. So 1 plus 3 times B into C. B into C is 20 minus A times 21 minus A is equal to A square. Now if you expand this, you get a quadratic in A. If you solve that quadratic, theoretically you should get the answer for A. Let us do this. So 1 plus 3 times 20 times 21 is 420 minus 21A minus 20A minus 41A plus A square is equal to A square. So this implies 3A square minus A square is 2A square. 3 into 41 minus 123A plus 1260 plus 1 is 1261 is equal to 0. So you can try to factorize this. So 1261 is nothing but 1300 minus 39. That is equal to 13 times 97. So this is 13 times 97 into 2. So effectively you have 26 times 97 and 26 plus 97 is 123. So you can factorize this as 2A square minus 26A minus 97A plus 1261 is equal to 0. This implies 2A times A minus 13 minus 97 times A minus 13 is equal to 0. This implies A is equal to either 13 or 97 by 2. So this implies the value of the side A is equal to either 13 or 97 by 2. That is 48.5. 48.5. So obviously 48.5 is a wrong answer because the sum of two sides is 20. So one side cannot go more than that. So 48.5 has to be discarded. So the answer will be A is equal to 13. BC will be equal to 13. And from this, you can get the remaining sides. 20 minus A. So B is equal to 7. And C is equal to 21 minus A is equal to 8. So the sides are 7, 8 and 13. In this question, given that in a triangle ABC, you are asked to prove that C cos A minus alpha plus A cos C plus alpha is equal to B cos alpha. So where alpha is some constant angle. So now what we do is C times, let us expand this. So cos of A minus alpha is cos A cos alpha plus sin A sin alpha plus A times cos C plus alpha is cos C cos alpha minus sin C sin alpha. So that is equal to, so if you expand this, so C times cos A times cos alpha, A cos C times cos alpha. So you have cos alpha here and cos alpha here. So if you take cos alpha as common, you have C cos A plus A cos C. And if you take sin alpha as common, you have sin alpha here and sin alpha here. So with sin alpha, you have C sin A minus A sin C. So now that is equal to cos alpha times, by projection rule, C cos A plus A cos C is nothing but B. And sin alpha times, by sine rule, A by sin A is equal to C by sin C. So A sin C is equal to C sin A. So C sin A minus A sin C will be equal to 0. So that is equal to B cos alpha, which is the RHS. Hence proved. Thank you. So in this question, you are asked to prove that cos C plus cos A by C plus A plus cos B by B is equal to 1 by B. So let us start with the left hand side, LHS. So cos C plus cos A. So I will take the LCM B times C plus A. If you take the LCM here, so cos C plus cos A times B plus cos B times C plus A by B times A plus C. So this is the LHS. So that is equal to, so LHS is equal to this. This is equal to, now let us try to regroup the terms. You have B cos C here, B cos C, and you have C cos B here. So I'll group those two terms. Plus B cos A, B cos A plus A cos B. So I'll group these two terms by B times A plus C. So from projection rule, what is B cos C plus C cos B is nothing but A. What is B cos A plus A cos B is nothing but C. So the numerator becomes A plus C by B times A plus C. So A plus C and A plus C gets cancelled. That is equal to 1 by B, which is the RHS. Hence it is proved. Thank you. So in this question, you are asked to prove that this big expression A times B square plus C square cos A plus B times C square plus A square cos B plus C times A square plus B square cos C is equal to 3ABC. So let us start from the LHS. So the trick is just regrouping of terms. So what I do is AB square cos A plus BA square cos B. So I'll group these two terms, that is AB square cos A plus BA square cos B. So I'll group these two terms plus AC square cos A, AC square cos A plus CA square cos C. So I'll regroup. So I'll this term and this term. So I'll group these two terms. And what are the remaining terms? You have BC square cos B, BC square cos B plus CB square cos C. So these are the two terms that I regroup. So now what happened once I done this regrouping? That is equal to, from these two I can take an AB as common. So if I take AB as common, you get b cos A plus A cos B plus, so in these two terms you can take AC as common, so you have C cos A plus A cos C plus, in these two terms you can take BC as common, you have C cos B plus B cos C. So again you can see that these brackets look like projection rules. That is equal to AB times what is B cos A plus A cos B is nothing but C, plus AC times what is C cos A plus A cos C, it's nothing but B, plus BC times C cos B plus B cos C is A. So you have ABC plus ABC plus ABC is 3 times ABC. So that's the RHS, hence the result is proved. In this question you're given that B plus C is equal to 3A. You're asked to find the value of cot B by 2 into cot C by 2. So very straightforward question of half angle formulas. So what is cot B by 2? Cot B by 2 is equal to root of S times S minus B by S minus A into S minus C into, so what is cot of C by 2? S into S minus C by S minus B into S minus A. So once you multiply these two, S minus C is getting cancelled here, S minus B is getting cancelled here. That is equal to root of S square by S minus A whole square. That's nothing but S by S minus A. So this is nothing but effectively S by S minus A. You need to find this. So how do I find S by S minus A? From the given information, B plus C is equal to 3A. So if I add A on both sides, A plus B plus C is equal to 4A. This implies 2S is equal to 4A. This implies S is equal to 2A. S is equal to 2A. Next, so B plus C is equal to 3A. B plus C minus A is equal to 2A. So what is B plus C minus A? B plus C minus A is nothing but 2 times S minus A is equal to 2A. 2 and 2 gets cancelled. So S minus A is equal to A. S is equal to 2A. S minus A is equal to A. So 2A by A is equal to 2. Okay, you can get this directly also because S is equal to 2A. 2A minus A is obviously equal to A. So you don't need to do this. So 2 is the answer to this question. Thank you. So in this question, you're asked to prove that BC times cos square A by 2 plus CA times cos square B by 2 plus AB times cos square C by 2 is equal to S square. In a very straightforward question based on half angle formulas. So what is cos square A by 2? Let us substitute the formula. So BC times cos square A by 2 is S into S minus A by BC plus CA times S into S minus B by AC plus AB times S into S minus C by AB. So this BC gets cancelled, CA gets cancelled, AB gets cancelled. That is equal to S times S minus A plus S times S minus B plus S times S minus C. So if you take S as common, S times S minus A plus S minus B plus S minus C. That is equal to S times 3S minus of A plus B plus C. And A plus B plus C is nothing but 2S. So 3S minus 2S is S. So S times S is equal to S square, which is the RHS. Hence, the proposition is proved. Thank you. So in this question, you're given that in a triangle ABC, tan A by 2 is equal to 5 by 6. Tan C by 2 is equal to 2 by 5. So if that is so, you need to prove that A, B, C are in AP. So how can we do this? So first, let us try to apply the half angle formulas. So tan A by 2 is equal to 5 by 6. So what is the formula for tan A by 2? Root of S minus B times S minus C by S times S minus A is equal to 5 by 6. So if you square it on both sides, you get S minus B times S minus C by S times S minus A is equal to 25 out of 36. Similarly, tan square C by 2 is equal to 4 by 25. So for tan square c by 2, so is the first equation. The second equation becomes s minus a times s minus b by s times s minus c is equal to 4 out of 25. Now let us multiply 1 and 2. So if you multiply 1 and 2, what happens? So s minus c, 1s minus c, these two gets cancelled. S minus a in the numerator and s minus a in the numerator gets cancelled. So you get s minus b whole square by s square is equal to, so once you multiply this, 25 in the numerator and 25 in the denominator gets cancelled. You get 4 by 36. So this implies s minus b by s is equal to, so 4 by 36 is 1 by 9. So if you square root this, you get 1 by 3. This implies 3s minus 3b is equal to s. So 2s is equal to 3b. 2s is equal to 3b. So a plus b plus c is equal to 3b. So a plus c is equal to 2b. Hence, a, b, c are in AP. So let us look at this question. In this question, you are asked to prove that b square cos 2a minus a square cos 2b is equal to b square minus a square. So how do we prove this? So b square times, what is cos 2a? Cos 2a can be written as 1 minus 2 sine square a minus a square times 1 minus 2 sine square b. This is the LHS. Now you are asked to prove that this is equal to b square minus a square. That means the remaining terms have to get cancelled out. Let us see whether they get cancelled out. So this is equal to b square minus a square, b square minus a square, minus 2 times b square sine square a minus a square sine square b. But you have to prove that this is equal to just b square minus a square. So effectively you need to prove that this is equal to 0. So will this be equal to 0? Yes, from sine rule we know that a by sine a is equal to b by sine b. This implies a sine b will be equal to b sine a. This implies a square sine square b is equal to b square sine square a. So a square sine square b minus b square sine square a. So this becomes equal to 0. Hence this is equal to b square minus a square. Since this happens from sine rule. Thank you. So in this question, you're given that angle A, angle B, angle C of a triangle are in AP, and small b by small c is equal to root 3 by 2. With these two informations, can you find the measure of angle A? So let us see how we can use the given information. So angle A, angle B, angle C are in AP. So can I write angle A as angle B minus some d? So angle B can be written as angle B itself. Angle C can be written as angle B plus d, right? A has to be equal to angle B minus some common difference. C has to be equal to angle B plus some common difference. Now, we know that the sum of all these angles, A plus B plus C, is nothing but, so if you add these three, you get B minus D plus B plus B plus D. D and D gets cancelled. That is equal to 3B is equal to 180 degrees. This implies angle B is equal to 60 degrees. So if three angles of a triangle are in AP, the angle in the middle has to be equal to 60 degrees. That's the conclusion. Next, let us go for the next information. B by C is equal to root 3 by root 2. The ratio of sides is root 3 by root 2. So can I convert the ratio of sides into ratio of the sines of their angles? Yes. We know that the sides are in the same ratio as sines of the angle. So B can be written as 2r sine B by 2r sine C is equal to root 3 by root 2. This 2r and 2r is getting cancelled. This implies sine C is equal to sine B times root 2 by root 3. But B is equal to 60 degrees, so sine B is root 3 by 2. That's equal to root 3 by 2 times root 2 by root 3. That is equal to 1 by root 2. So sine C is 1 by root 2. This implies C is equal to, so if the angle C is acute, so C has to be equal to 45 degrees. If C is obtuse, C can be equal to 135 degrees. So, but already we have seen that angle B is equal to 60 degrees. So if angle B is equal to 60 degrees, angle C cannot be equal to 135 degrees. Because the remaining measure of angle for A and C combinedly is 120 degrees. So C cannot be 45 degrees. So C cannot be 135 degrees. So C has to be 45 degrees. So angle B is equal to 60 degrees. Angle C has to be equal to 45 degrees, right? So angle A has to be the remaining angle, that is 75 degrees. So 75 degrees is the right answer to this question. Thank you. So in this question, you're asked to find the value of a square plus b square plus c square by r square for any right angled triangle. So how do we analyze this? So let us say that in this triangle, angle B is the right angle. Let us suppose that B is the right angle. So any angle can be right angle without loss of generality. Let us suppose B is the right angle. So A by sine A is equal to B by sine B is equal to C by sine C is equal to 2R. So I don't know about A and C, but I've assumed that B is right angle. So sine B is equal to 1. So B has to be equal to 2R, right? This is one relation that we have. And because B is the right angle, B square has to be equal to A square plus C square. So this A square plus C square becomes another B square. So A square plus B square plus C square becomes 2B square divided by R square is nothing but B square by 4, right? R square is B square by 4. So that's equal to B square and B square gets cancelled. You get 8 as the answer. So in any right angle triangle, this value will always be equal to 8. Thank you. So in this question, you're asked to prove that C by A plus B is equal to 1 minus tan A by 2 tan B by 2 by 1 plus tan A by 2 tan B by 2. So let us simplify the LHS and let us simplify the RHS. Let us see whether they converge to the same expression. So if you take the LHS, nothing but C by A plus B. From sine rule, I can write C as 2R sine C by 2R sine A plus 2R sine B. So I can take 2R common and cancel it out in all the terms. So this is equal to sine C by sine A plus sine B. That is equal to, so sine C can be written as 2 sine C by 2 cos C by 2 divided by, what is sine C plus sine D? 2 sine C plus D by 2 into cos C minus D by 2. So 2 and 2 gets cancelled. And now what is A plus B by 2? We know that A plus B plus C is equal to 180 degrees. So A plus B is equal to 180 minus C. And A plus B by 2 is equal to 90 minus C by 2. 90 minus C by 2. So what is sine of A plus B by 2? That's nothing but sine of 90 minus C by 2, which is cos C by 2. That is equal to sine C by 2 cos C by 2 divided by, so sine of A plus B by 2 is sine of 90 minus C by 2 cos C by 2 cos of A minus B by 2. So this and this gets cancelled. So effectively you have sine of C by 2 divided by cos of A minus B by 2. So this is how the LHS has got simplified. Now let us try to simplify the RHS. So how can you simplify the RHS? So let us convert tans into sine and coses. So 1 minus sine A by 2 sine B by 2 by cos A by 2 cos B by 2 divided by 1 plus sine A by 2 sine B by 2 by cos A by 2 cos B by 2. So that is equal to, so if you take the LCM, you get cos A by 2 cos B by 2 minus sine A by 2 sine B by 2 divided by cos A by 2 cos B by 2 plus sine A by 2 sine B by 2. So that is equal to, this is of the form cos A cos B minus sine A sine B. It's nothing but cos of A plus B by 2 divided by, this is of the form cos A cos B plus sine A sine B. That is cos of A minus B by 2. And again A plus B by 2 is 90 minus C by 2. Cos 90 minus C by 2 is sine C by 2 by cos A minus B by 2. So can you see that both of them, both LHS and RHS has converged to the same expression. Hence LHS is equal to RHS. So hence this is equal to this. So in this question, you're given that in a triangle ABC, the value of sine A cos B is root 2 minus 1 by root 2. And the value of sine B cos A is 1 by root 2. So if these two informations are valid, what is the area? So what is the nature of this triangle? So you're asked to find whether the triangle is equilateral, isosceles, right angle or right angle isosceles. So from these two informations, what can you conclude? So this looks like the formula, this looks like the terms in the formula sine of A plus B and sine of A minus B. So we know that sine of A plus B is equal to sine A cos B plus cos A sine B. That is equal to root 2 minus 1 by root 2 plus 1 by root 2. That is equal to minus 1 by root 2 and plus 1 by root 2 gets cancelled. Root 2 by root 2 is 1. So sine of A plus B is equal to 1 implies A plus B is equal to 90 degrees. The sum of two angles of the triangle is 90 degrees. So by now you would have seen that angle C is equal to 90 degrees. Hence right angled triangle. So let us further analyze this. What is sine of A minus B? Sine A minus B is sine A cos B minus cos A sine B. That is root 2 minus 1 by root 2 minus 1 by root 2. That is root 2 minus 2 by root 2. That is 1 minus 1 by root 2. So obviously sine A minus B is not equal to 0. That means A is not equal to B. A is not equal to B. Hence angle C is equal to 90 degrees and angle A is not equal to angle B implies the side A is not equal to side B. The right angled sides are not equal. So C is 90, A, B, angle A and angle B are different. So sides A and B are different from one another. Hence I say that this is just a right angle triangle, not isosceles right angle triangle. Thank you. So in this question you're given that angles A, B, C of a triangle are such that angle A is obtuse, then tan B, tan C will be less than which of these numbers? 1 by root 3 by 2, 1 and none of this. So how can we analyze the given information? So angle A is obtuse, that means angle A is greater than 90 degrees. So that means angle B plus angle C will be less than 90 degrees, right? Because A is greater than 90 degrees, so the remaining angle should be less than 90 degrees. So this implies tan of B plus C is greater than 0. Because B plus C is an acute angle, tan of B plus C has to be positive. And this implies tan B plus tan C by 1 minus tan B tan C has to be greater than 0. And in the numerator, both B and C are acute angles because the sum is acute. Hence, each of these angles have to be acute. That means tan B and tan C are positive. So the effective fraction has to be positive and the numerator is positive, hence the denominator has to be positive. This implies 1 minus tan B tan C has to be greater than 0. This implies tan B tan C will always be less than less than 1. Hence the value of tan B tan C will be less than option C is the right answer. Thank you. So in this question, you're given that in a triangle ABC, angle B is equal to 90 degrees. If that is so, what is the value of tan square A by 2? And this is a very straightforward question, directly based on Napier's rule. So what is Napier's rule? Tan of B minus C by 2. So is equal to B minus C by B plus C times cot of A by 2. So from this rule, is there any way in which you can get tan square A by 2? So what I do is, it's already given that B is 90 degrees. So if you take the triangle, angle B is 90 degrees. So obviously angle C plus angle A will be equal to 90 degrees. So C will be equal to 90 degrees minus A. So if you substitute both of them here, you get tan of B is 90 and C is 90 minus A, minus of 90 minus A by 2 is equal to B minus C by B plus C times cot of A by 2. And this 90 and this 90 gets cancelled. So minus of minus A is plus A. So tan A by 2 is equal to B minus C by B plus C. Cot A by 2 is 1 by tan A by 2. So this tan A by 2 gets cross multiplied. This implies tan square A by 2 is B minus C by B plus C. Thank you. So in this question, you're given that in a triangle ABC, R1 is equal to 2R2 is equal to 3R3. If that is so, what is A is to? So what can we write from this equation? So we know that R1 is delta by S minus A, R2 is delta by S minus B, and R3 is delta by S minus C. So delta by S minus A is equal to 2 times delta by S minus B is equal to 3 times delta by S minus C. So this delta is getting cancelled. That means 1 by S minus A is equal to 2 by S minus B is equal to 3 by S minus C. So if you have seen equations like this before, this equation simply means that S minus A is to S minus B is to S minus C is 1 is to 2 is to 3. So the ratio of S minus A, S minus B and S minus C is 1 is to 2 is to 3. So I can write S minus A as x, S minus B as 2x and S minus C as 3x. So this implies, if you add all this, 3s minus of A plus B plus C, 3s minus of A plus B plus C is equal to x plus 2x plus 3x is equal to 6x. And A plus B plus C, as we know, is 2 times semi-perimeter. So 3s minus 2s is S is equal to 6x. So you got S is equal to 6x, and 6x minus A is equal to x implies A is equal to 5x. 6x minus B is equal to 2x implies B is equal to 4x. And if you divide these two, you get A is to B is equal to 5 is to 4. So this will be the answer to this question. Thank you. So in this question, you're given that A square plus C square is equal to 2002 times B square. If that is so, you're asked to find cot A plus cot C by cot B. So how do we do this question? So first, let us try to analyze if there is some relation between the given relation and the
question that is being asked. So a square plus c square is equal to 2002 b square. This is a relation in the sides. This is a relation among the angles. So how do you convert the relation among sides to the relation among angles? So one of the way is sine rule. So a square plus c square by b square is equal to 2002. And what is a square? A square can be written as 4r square sine square a, because a is equal to 2r sine a. So we have 4r square times sine square a plus sine square c by 4r square times sine square b is equal to 2002. This 4r square and 4r square is getting cancelled. Now sine square a plus sine square c by sine square b is equal to 2002. So this is one of the relations that we have from the given information. So now how does this relate to our given question? So let us try to convert cots into sines and coses, because I don't have any formula for direct cot A. So this is cos A by sine A plus cos C by sine C by cos B by sine B. So that is equal, if you take the LCM here, cos A sine C plus sine A cos C divided by sine A sine C times cos B times sine B. This is how the expression simplifies. That is equal to, so this is sine A cos C plus cos A sine C. This is sine of A plus C times sine B by sine A into sine C times cos B. And A plus B plus C is equal to 180 degrees, because ABC is a triangle. Hence A plus C can be written as 180 minus B, and sine of 180 minus B is again sine B. So you have effectively sine square B by sine A sine C cos B. So the given expression simplifies to this. So if you can find this, then you get the answer. You have this sine square A plus sine square C by sine square B is equal to 2002. So can we relate these two? That's the question now. So now if you very carefully look at these two equations, there is some similarity between these two equations. You have sine square B and sine square B, but in the denominator you have sine A sine C cos B. Here you have sine square A plus sine square C. So is there any way in which you can convert this into this? So usually you have seen formulas like this where additions are getting converted into multiplications, the topic of conditional identities, right? So I'll try to convert this into a conditional identity. So this is 2002 by 1. So I'll use dividendo, that is sine square A plus sine square C minus sine square B by sine square B is equal to 2002 minus 1, that is 2001 by 1. Now let us try to examine this numerator. Sine square A plus sine square C minus sine square B, if A plus B plus C is equal to 180 degrees. So you can simplify this expression to 2 sine A sine C cos B. So this is nothing but 2 sine A sine C cos B. So we have seen how to simplify expressions of this type. This comes under type 2 of conditional identities. So if you substitute this, you get 2 sine A sine C cos B by sine square B is equal to 2001 by 1. Hence this will be equal to 2 divided by 2001. Thank you.